Hey. Geliyor değil mi? Test. Oh, it works.
Good morning, everyone. We're going to go ahead and begin with the first speaker here. This is Thomas, who I've learned today is a Ethereum core developer and the founder of Nethermind, as well as TwinStake. And he's going to be talking about bringing core staking innovations to L2 and to institutions. Our first topic, please go ahead.
Thank you. Hi, everyone. That's a loud microphone. All right, so why talking about core staking innovations and institutions in that sense? So let me solve this one. Okay, so for the last 5-6 years, I've been working very closely with the core development of Ethereum, working on the implementation of it, and then building lots of integrations, and in the last few months particularly looking a lot into rollups, the plans for decentralization, for staking on rollups, the fees, MEV, and so on. So working with Flashbots also for the last and TwinStake actually was created 1.5 years ago as a collaboration between the financial institutions world and the core development team at Nethermind. So there's a joint venture between Weban from the Howard family and Nethermind's team. And that's why we talk together about the EIPs and institutions. So thinking about how exactly we're bridging that thinking process from the internals of the core development all the way to how it affects the big players on the market, how it affects the markets actually. And this was really thinking always for Nethermind, thinking about creating the approach to developing Ethereum in a way which brings the ideas, the thinking of products for the largest of the institutions, and slowly bringing the whole financial markets and governance and the world to Ethereum. It's happening now. Maybe it wasn't that obvious a few years ago when we were all starting. And when you think about all the L2s, which is a big thing happening now for Ethereum, right? So all the scalability comes with the layer 2s, and this is L2Beat, fantastic dashboards that tracks layer 2s. There is huge expectations. There are huge expectations about L2s bringing new opportunities for staking, for additional yield. And I think it's still not very clear how each of those major L2s, think about Arbitrum, Optimism, zk-Sync, Scroll, Starknet, Polygon, and so on, how exactly they will resolve the staking opportunities for their centralization of their protocols. And some of these conversations in the last few months take a lot of different paths, showing that it's still probably 1 year ahead for many of those L2s to decide where exactly they'll be going with the centralization. And some of the models that were appearing recently are the based rollups, which are very strongly promoted or maybe explained and discussed under leadership from Justin Drake, and the proof of governance, which kind of got the name from John Charbonneau's research. And the first one says that L1 will actually be the place for sequencing layer 2s. So if we have things like Ethereum and Tyco as a rollup, or you can think of Optimism as a rollup, it will be the block builders that will be sending transactions to the smart contract on layer 1. The smart contract on layer 1 will do the basic verification whether those blocks proposed by the proposers are valid, or following the most basic formatting parameters and content rules of what transactions can be included. And then, depending on the ordering of the incoming transactions within the smart contract, we'll be receiving the information about sequencing on L2, like the ordering of blocks on L2. Canonical L2 will be constructed entirely within the internals of the smart contract on L1. How it affects the staking and the yields? Well, it actually brings all the MEV to the layer 1 validators. So how does it really happen? Like normally when you have the MEV payment, it goes to, majority of it nowadays goes to the validators on the actual chain that we are sequencing. So the payments from the MEV block builders are being shared with the validators, and here the validator is actually the builder of the layer 1 block. So the sequencer of the layer 2 is looking at this layer 2 transactions and inputs them inside the layer 1, and if different layer 2 blocks are competing with each other, then actually the ordering between them is being resolved by which one pays the most to the layer 1 builder. So layer 1 builder captures all the MEV. So as we know that much of the Ethereum staking nowadays is institutional, all that MEV will be flowing to the institutions and, well, all the solo stakers as well on L1 if the base rollups are being adopted. And the additional proposal is that with the base rollups, we actually have the cross-chain atomic sequencing with the ability to use the layer 1 as this coordination layer of pushing the blocks that can be handling all the bridging atomically between different L2s. The second proposal with the proof of governance also affects a lot our thinking about the staking, because it very likely suggests that some of the L2s, if they follow the proof of governance model, which is like an extension of the centralized sequencer, extension in a way that instead of having one controller like the foundation or the core builder of the network designating a single sequencer, proof of governance says that that role is delegated to the token holders that represent the governance, either token holders or other governance mechanisms that defines L2 governance. And they select a small group of sequencers, and they can vote them in or vote them out. So there are no protocol rules for adding or removing permissionlessly the sequencers. It's just all voted in. Now, it means that usually we have the staking for protocols like Tendermint or solutions similar to Polygon proof of stake staking that define the need for the block rewards and the yields to the sequencers on layer 2. For the simple sequencing that is delegated by the foundation, like centralized sequencers or the proof of governance sequencers, those payments are usually much, much lower because you introduce more of the trusted sequencing. So it's trusted or governed, overseen sequencing, and you don't have to manage the security of the network through the stake that is being slashed, really, because the slashing appears by simply voting the validator out. A few other things that probably are already widely discussed in many other presentations here, so I'll skim over them a bit more fast. So restaking, bringing the additional opportunities for those who are operating validators on layer 1 to get additional yield from using the same deposited ETH and staking it again for securing other rollups. And while we can expect that the existing major L2s will bring some of their own solutions for securing the chains, they most likely will use their own native tokens, or as we mentioned, the centralized or proof of governance sequencers. With restaking, we can expect that something like rollup as a service models will very often try to borrow the security from the main Ethereum chain. And now, from the institutional perspective, this is probably much more risky than what we see now in a very basic vanilla staking on Ethereum. Institutions even nowadays are a bit timid to go with the liquid staking solutions. Even Lido for many of the compliance teams is a bit too far. So using smart contracts to go there, using something that starts to look like DeFi, it's not accepted by many of the institutional teams for compliance or any regulations. So with restaking, I think that much of the delivered added value from the operators will be an ability to provide the very detailed risk assessment and auditing of the behavior of the chains that are reusing the stake from the layer 1. So we'll have institutions picking, like cherry picking the absolutely top, well audited and tested and trusted chains that will be borrowing from layer 1, borrowing security for the restaking like icon layer. DVT solutions, so things like OBOL, SSV, also a few other solutions, I think SafeStick, Diva, Claystack, probably others. So this is bringing the distributed validators to Ethereum, so distributed validator keys, bringing potentially additional geographical diversity, additional support for the limited downtime for mostly solo stakers, but also potentially bringing down the insurance costs for the large operators. So we may expect the institutions will be slowly demanding the distributed validator implementations. However, there is some balancing expected, as the distributed validator operations usually be bringing up the costs of operations for the node operators. So on one side, we'll have increased costs. On the other side, we may have the decreased cost of insurance and the pressure from the clients to introduce it for additional safety and geographical decentralization. So when you think about the inactivity leak problems, those might be actually solved by the fact that we'll be operating distributed validators in assets where the different validators will be in totally different locations. So if some of the regions go down, then the other regions will be maintaining the key signing. Now, one more thing that I'm believing that for L2s will be quite important is that we can expect the proving markets to appear. However, for the proving markets, I feel that they will not bring the same opportunities as staking. So we'll not be talking about yields, but the sheer computation payment. So more like for those institutions that are asking, is there business for us? Thinking about, is it something to add on top of the yield? Very likely not, but we'll see. Maybe there'll be some innovation here. Now, quick overview of a few EIPs that are coming to Ethereum. So 7002 execution layer triggerable exits. This, I believe, is something that, for me, was expected for the longest time. It brings the ability to invoke the exit from the Ethereum consensus layer, exit of the deposit, back to the withdrawal address without interaction with the node operator. So it brings this like fully non-custodial feel to the institutions. Nowadays, institutions have to expect that they can communicate with the node operator that will pre-sign for them the voluntary exit messages. This makes it, at the beginning, a bit awkward, because for regulatory purposes, many of the node operators say that they are non-custodial. But for a very short moment, or at the time when the deposit is made and before we signing the withdrawals, this is not the case. And with the previous EIP 7002 coming in the hard fork, in the network upgrade, probably the one after Cancun, the one that comes now actually fixes like it in a faster way, in a simpler way. So now when you're signing the voluntary exit, there used to be a security mechanism that was saying that it's valid only for the 2 network upgrades. With 7044, this becomes perpetually valid, which means that there's slightly less risk before we introduce 7002 for those exits to become like custodial again. EIP-4788, so access to the beacon block root in the EVM. It's very important. It connects the execution layer with the consensus layer in a way that the execution layer can read all the data related to the consensus layer behavior, which means that in the consensus layer you have all the information about the rewards, about the exits, about slashings, and suddenly you can create set of the financial instruments for institutions to manage better the risks related to slashing. So you can build some automated on-chain insurance products. You can start creating the yield-related derivatives, where you may say that there is, like you convert floating to fixed by saying that if there is more validators joining the network than planned, then you actually pay out that difference on the, so we know that when more validators come to the network, then the yield drops. So if I want to change it to the fixed payment, then I would like to actually read the information about how many validators are joining the network and make some kind of derivative product that pays the difference on the execution layer. And the same for restaking, both this one and, sorry, this one. So when we think that forcing exits by restaking on slashing from the restaked validators, and tracking the security levels, actually knowing from the restaking position. So if I'm reusing my deposit to secure some layer 2, and the deposit actually exits layer 1 or is becoming slashed, I want to know about it as fast as possible and possibly react on the execution layer. So with 4788, I will have the access to that. Now, EIP-6251, it was a bit more famous, so there were a few blog posts about it. The max effective balance increase. It says that no longer we're talking about staking only 32 ETH per validator, or like per validator infrastructure set. If we have large node operator for institution, very often they'll be accepting like deposits in the size of tens of thousands of ETH or more. And for all of this now, there's lots of validators and the beacon chain clients that have to be operated. There's also a significant cost of sending deposits and creating the keys for withdrawals for all of those. So with 7251, we can expect significant cost reduction for operating the infrastructure for the large depositors. So I have slightly mixed feelings about this one, because it feels like it brings some potential cost savings to the large operators, which is usually seen as a centralizing force, but probably this is negligible comparing to all the other centralization effects that we already have to deal with. And the last thing that I want to mention, so recently Coinbase announced the identity verification and KYC solutions on chain based on Ethereum attestation service. And somehow I believe that the Ethereum attestation service will be one of the most important things that will be happening on the institutional side on Ethereum in the next few years. So from the very beginning of working on Ethereum, I was thinking that creating robust systems for reputation tracking and for claims, they will be actually bringing the certifications and claims for the reputable institutions from the off-chain world and bringing them all to the on-chain will help us to start bringing the same like under collateralization for finance and the same level of checks and creating of the like tracking of the safe assets on-chain as we have in the traditional finance, which means that we don't really have to get the connection between the off-chain and on-chain world. We don't need it. We do it nowadays only for the reason that that data does not exist on-chain yet, that we've built over many, many years, like tens or hundreds of years, the sets of certifications and rules and attestations that exist in the off-chain world. So we can ask people about credentials, we can ask universities to confirm whether they graduated the university, we can ask the professional bodies about certifications, we can ask large financial institutions whether the assets that are deposited in a given account can be tracked all the way to the source. As soon as we manage to move all those certifications and credentials on-chain, no longer will need to connect the two worlds. So institutions that will try to KYC the assets flowing to their, let's say, DeFi protocols, will be able to verify everything, every single claim on-chain. Now, I think this is very much related to the many discussions about the censorship on the protocol level. There is some expectations very often that, or maybe there is a risk that the protocol builders, the core developers, facing the needs of the governments and institutions, have to bring the tools of following like the sanctions of particular countries, restrictions, censorship on the protocol level. The truth is that if you don't introduce it on the protocol level, then there is absolutely no limitation to introduce it on the level of the asset zones or like attestation zones. I can still restrict the flow of funds towards the institutionalized DeFi, towards the on-ramp and off-ramp zones by tracking properly the on-chain KYC and attestations. So if I'm an institution that doesn't want to deal with the tainted assets, with assets that have some kind of negative claims on them, of the source that cannot be verified and so on, then I may join the set of contracts that are always tracking the source all the way to minting or some clear certified on-ramp sources. So what I expect is that entirely neutral protocols will be hosting the zones of totally clean assets that are fully certified, and those will be much more liquid and accepted by particular sets of institutions and governments. And there might be different subsets of assets on the chain. So we'll slowly see a bit of compartmentalization of assets on chain. And we don't need to introduce that on the protocol level because this will happen nonetheless. And this will introduce also a bit more of a acceptance that there must be some kind of coexistence of this compartmentalized asset zones on a single protocol. Because the rules, the sanctions may change over time, and there's no need for bridging, and that separation can be introduced on the smart contracts level. Maybe for many of us it might be feeling like as a disappointment, but I think it's unavoidable. And on one side, it tells institutions that the chain will be seen soon as a fully regulated space with all the certifications and KYC and KYB on chain. But it also tells the whoever tries to fight for privacy brings that answer that on chain the space of the contracts that they will be able to interact with will be limited over time, and it will be tightening, and the liquidity will be always much drier because any privacy-oriented transfers will have to go through this like tainted asset zones, a bit like probably nowadays like gray black markets. Thank you so much for listening, and if there are any questions, if there is time for questions.
Yeah, I think we have time for a few questions from the audience here. I'd like to take the first one here, which is, you mentioned EIP-7002, and that one's very near and dear to my heart. And I noticed it did not meet, it didn't get in, I don't believe, or at least currently under consideration, unless I'm wrong, the Cancun DNAB update. But there's talk of it coming in, I guess it's Electra that's going to be the next one. Can you comment on that, or maybe share some thoughts about what the community can do to start advocating for its inclusion?
Maybe improving that communication between the needs of institutions towards the builders. So any teams that connect, that build products for institutions and also are responsible for maintaining chains will be able to push for updates like this. However, when we think about current core dev teams, they're very often already connected to institutions. So as I showed, TwinStake is kind of collaboration of Nethermind with enterprises. Besu, Teku come with the space of consensus, connecting lots of enterprises to the needs of the core builders. Collaborates with Optimism and Prism teams. So I'm not sure. I think this seems quite obvious that we need it. Maybe the ideation, formalization required some time and people to just feel a bit more comfortable with it and to actually start understanding the power. So maybe through the talks like this and more conversations about what changes for users, it's easier to implement this.
Perfect. Are there any other questions from the audience here?
Hi. Quick question on one of the last points that you raised. I don't know whether I understood well, but if I understand, let's say, functions should be integrated at protocol level rather than application level. The problem is that if they are integrated at protocol level, that significantly increases the risk of regulatory capture. Because, for instance, under the markets and crypto assets regulation, there is the infamous reciter which says that services are provided in a fully decentralized manner, whatever that might mean, then potentially they might be within scope of the... So wouldn't you say that there should be full and complete separation between the protocol and the application layer at all times, so that the protocol is unassailable, so to speak, and then effectively at the application layer, well, then there's the opportunity to either go down the unregulated route or the regulated route. Thank you.
So the same, I want to try to make sure that I understand properly the suggestion. So I'm not saying that on protocol levels. I think that protocol should be seen more and more as a technological layer that is totally disconnected from decisions on where are the assets separated. That regulators will accept the fact that there will be total traceability and separation of assets according to some of the claims that the protocol supports. It's just that the claims as a very technical system. The claims will not be named or specified in the protocol. The protocol just supports claims because of its primitives that are supported, like signatures and so on. And the claim systems for the very neutral set of smart contracts are landing on Ethereum, are available. So I think that that's what we should push for, that we will not accept any regulatory capture on the protocol level, that the core developers will not be following any specific rules of sanctions, not because they want to lead to avoidance of those mechanisms, but because we know that those mechanisms can be extremely efficiently introduced on chain through the set of smart contracts and claims, which means that any regulator that has control over some assets will know that they practically can fully control the flow of those assets and in the direction and track the source. I think this is unavoidable, but also it says that, this gives us a bit of ability to make clear claim that, protocol is neutral, but it doesn't really change anything. Whether you split it between two chains or you just split it between two asset zones on the same chain, the result is the same.
All right, well, thank you very much. Please, another round of applause for our speaker this morning.
Oh, yeah, sorry. Great. Classic. All right, hang on. Let's see. Sorry.
It's open to weak error resolution scale.
Yeah. Okay, hang on.
All right, thank you all for being patient there. It never fails. There's always technical glitches somewhere in a presentation. So I'm very pleased this morning to announce our second speakers here. Joining me here is Jason Ramirez, both with the Ethereum Foundation. And today they're going to be talking about replacing execution clicking setups.
Great. Thanks. So as you said, I'm Jason, also known as Carver online. I've been at the Ethereum Foundation for about 6 years, formerly working on Python tooling like PyEVM, and more recently on the Portal network and the client for it called Trin. I'll get more into the Portal network later, and in a couple of minutes I'll hand it to Daniel, but we got a lot to cover, so we'll just get started. So we're looking at staking and the future of it without a full weight execution client. So how are we going to address this question? About what are we interested in aiming at? What's our ideal for what it would look like to have a lightweight staking system? And then we'll back up to where we are today, where Daniel will do the technical review of how the consensus client and the execution client talk to each other during staking. And then we'll come back to looking at active lines of research right now and how they each move lightweight staking forward and add up together to being able to get the full state execution client out of the picture. So let's look at lightweight staking. What does that mean? It can mean a lot of things, but obviously in general, we want it to be easy to stake. We want it to be easy to start, easy to administer the setup, and there's several impediments to that, but the one today is disk space usage. So we would love to be measuring disk space usage in the 100 gigabyte or less range, or gigabyte or more range. And the execution clients play a significant role in that, of course. And they are incredible pieces of machinery, and they're always getting better, but it's hard to imagine optimizing them to the point where they can hit these targets while still being a full client. So that takes us to the point of view of thinking, okay, well, it seems like we're going to have to seriously consider the staking setup altogether to hit this goal. So in order to really understand what that would look like, we have to kind of back up and see how our execution clients use during staking today. And so for that, I will hand it off to Daniel.
Yeah. Hi everyone, my name is Daniel. I have been contributing on the Ethereum ecosystem for the last year and a half, and now I'm part of the Ethereum Protocol Fellowship. So let's talk about how staking. Well, as all of you might know, running a validator node is something that uses a lot of, but why? Well, most of the blame can be attributed to the execution, because if we do a quick comparison, we can see that the lightest execution client uses about 8 times as much disk space as the heaviest consensus client, and the same thing happens with other parameters like memory, bandwidth, and other things like that. But why does this happen? What does the execution client do that needs all of these resources? Well, it's mainly 3 things: starting up the node, building blocks, and validating blocks. So let's see how this works under the hood. Well, the 2 clients use the engine API to coordinate all these tasks, and I will be using these diagrams, sequence diagrams, to explain all of this. So just a quick introduction. The vertical line on the left is the consensus client, and the vertical line on the right is the execution client. The horizontal lines just indicate the API calls or the messages that they send to each other to communicate. So with starting the node, the first thing that happens is that they do a handshake. They exchange what engine API methods are available on each one of them. And after that, the consensus client calls fork choice update, which basically tells the execution client, this is the latest data I have on the fork choice, update your fork choice, and the execution client will verify that data and update its fork choice if it's correct. Now with block building, the consensus client is assigned to propose a block and calls fork choice updated, but this time with a second parameter called payload attributes. This indicates the execution client to update its fork choice, but to also start building an execution payload. And after some time, the the consensus client will retrieve this payload, calling get payload. And finally, block validation. For validating a block, the consensus client receives a beacon block. It extracts its execution payload and sends it to the execution layer to get verified by using the method new payload. I wrote an article explaining all of this in more depth. This is the QR code to it if you're interested in learning more about the engine API. But yeah, what does all of this mean? Well, it means that to run a validator node, you need one client that is able to respond to 3 endpoints: new payload, fork choose updated, and exchange capabilities. And what do we need to be able to respond to those endpoints? Well, we need a mechanism to validate blocks, a mechanism to build blocks, and access to the chain data. And well, how can we do that on a lightweight manner? We can't right now. The only way to serve those endpoints is by being a full-weight, heavy execution layer client. But there is some research being done right now by researching how we can solve this, and Jason will tell you all about that.
Okay, so what are we going to do about this? Where do we go? So a quick recap of some of the main challenges we have here is we're going to need to validate blocks from peers. We're going to need to propose new blocks. And perhaps outside of the staking scenario, we're going to want to look at the chain state sometimes within it. So we'll do a little bit of a spoiler here about some of these technologies. So Verkle, Proposer Builder Separation, and Portal are going to help us address these things. So let's look at how that's going to be possible. First, I'll say that Portal is where I've spent my time in the last year or two. That's where most of my expertise is in. But Verkle and PBS are core and critical components for this plan. So I'm going to do the uncomfortable thing and talk about them anyway, despite not being an expert in them. And I have a little bit of an ulterior motive here, which is if there are experts in them out there watching this, and I say something about the future of how they fit into lightweight staking that you disagree with, then at me. Let's figure it out together. So let's look at validating peer blocks. Now, just to confirm, this is not an optional thing. We can't just skip this step, because if we skip this step, then proposers can make arbitrary state changes on the network, and they become canonical. We absolutely must validate blocks coming in from peers. So traditionally, the way we're doing this is we get the block from the peer, we execute the transactions in that block against the chain state, and then compare the final state root against the block committed to by the peer. And to do that, we need the full client. Unless we include the state accessed during that block along with the block itself as it's passed around peers. And by doing that, in theory, we can have a stateless client that reads the state out of the bundle with the block while executing the transactions in it. And technically, it is possible to do that even with Merkle-Patricia trees today. The challenge is that they're too big. Well, they're not always too big. In fact, often they would be just fine. But it is possible for an adversary to construct a block in a way that would make them much too large and would drag the network to a halt. So it's a non-starter to include with the current tree structure. And that is one of the key benefits behind moving to Verkle. So Verkle is a tree structure that will allow us to create the state witness, which is just another way of saying the list of state that was accessed during the block and the proof that that state belongs to the canonical chain. So Verkle allows us to create the state witness that's small enough, reliably small enough, to bundle with the block being passed around to peers. And so in this future, the stateless client can execute those blocks without keeping any state data locally. And I'm going to plant this thought here. We won't go deep into it this moment, but when you rip the state out of a client and make it stateless, it can now only do this one thing, which is verify the transactions in a block that have an attached state witness. So with Verkle, we can address validating peer blocks, but that doesn't help us propose new blocks yet. So let's look at proposing new blocks, which is the process of looking at the transaction pool and including them. It's your slot, you're the proposer. You've got to look at the transaction pool, throw them into your block, order them for fees, and this is obviously going to require state access. And really, there's no way around this. So it kind of seems like we're stuck until the moment that we realize that we can separate the roles. So you can be a proposer and then ask someone else to build the block for you. And that is the essence of proposer-builder separation. So it's your slot. You say, hey, builder, make a block for me. And in a post-Verkle world, you act in many ways like a validator of that block as if you were getting it from a peer. You still have to make sure that that block follows the state transition rules. But that block will include the state witness. The block from the builder will include the state witness, and so you as the proposer can validate it and then start passing it around to your peers. Now, MEV Boost is kind of an informal proposer-builder separation that's available today, of course. So why even include this? It seems like we're kind of already there. And the answer is that we want lightweight staking to be something that we as a community are happy about if every staker is doing this, right? And there are reasons to think that we might not be happy as a community if 100% of stakers were using MEV Boost in today's iteration. There are some open questions. There's reasons why we want to formalize it more broadly into proposer-builder separation mechanism. So for example, the story for transaction censorship is a little bit weak in MEV Boost right now. But we're a lot of the way there, and there's some great work happening on formalizing this. So we're kind of there. Maybe we're done. We've validated the blocks. We're proposing new blocks, and really those are these core features, those core needs of a staker. But I want to come back to this question of what is the stateless client capable of? And as I mentioned before, basically nothing. It's useless. It's useless. If you want to do things like look up your own validator balance, you can't do that on a stateless client. You can't do anything with it besides validation of blocks. And so there are lots of things that we might want to do, like submitting transactions for withdrawals, monitoring the deposit queue. There's even reasons to think that we might, if say proposer-builder separation is in a sort of offline mode, you might want to at least build an empty block, and you would still need some state to do that in order to create the new state root. And so there are reasons why we might want access to some state on demand. So if you take a stateless client and you add in the concept of on-demand state, then you get what I'm going to call a just-in-time state client. So this JIT state client is something that is an important piece of the puzzle for how do we get towards this lightweight staking. And our answer for that is the Portal network. So let's look at the Portal network and how that can help us get to JIT state clients. So Portal is a network that was specifically designed for the idea of on-demand selective access to state in a way that's verifiable against the canonical chain. So you can join this peer-to-peer network, and you store some small sliver of the chain. And for any pieces that you don't have, you just go find the peer that does have it and download it, that you have enough information between what the peer gives you and you already have. Those together are enough to validate this data against real chain information. So when we take that on-demand state access and we pair it together with a stateless client, right? We can stand on the shoulders of the stateless client teams here, and we can get block verification. Now we're on our way towards a JIT state client, or really we're there. It's worth noting here that, of course, to get state on demand will necessarily have higher latency. We're never going to be as fast at finding peers who have state and downloading it from them as we would to load it in a single shot from a local SSD. But if that means reducing our disk storage needs from a terabyte to a couple gigabytes, we figure that's a trade-off that a lot of people would be happy to make, especially when you're not in the middle of, say, proposing or block. We're talking about using this on-demand state access for sort of non-critical path moments. So how do we get to this JIT state client? It's useful to look at how, at this as sort of two axes. And there's on-demand state, which I've just talked about with Portal. And then there's, of course, the execution clients that have already been built. And the idea is that if we take Portal, which gives us on-demand state as we're heading towards it now. This is, by the way, Portal is in sort of an alpha situation. You can look at it and check it out, but it's probably only ready for you if you're happy browsing GitHub repos. It will be ready for more people soon. So we take the Portal client and we add in the stateless client. We embed a stateless client, and we've got a JIT state client. And that stateless client is a relatively straightforward thing to pull out of existing execution clients. They just can kind of rip out all the local state storage and learn how to read the state witness that's embedded with the block. But the question is, these execution clients might want to make JIT state clients themselves. And the question is, how do they get there? Well, from the stateless client to a JIT state client is sort of an unknown path. There's a lot of challenging questions that of course, we've looked at from the Portal network, and we've been able to design our clients around those needs from the beginning. And it's not clear that, say, taking the existing execution client network and adding some features will help get them to on-demand state access. So, if they want to build their own solution, they can. And, we'll race them there to the JIT state client. It'll be fun. But, of course, they do have the other option of just joining the Portal network, right? So they can either import a Portal client into their own execution client, or they can implement their own version of a Portal client using the public specs from Portal network. And we, of course, welcome that. And if there are any client teams out there listening that are interested in this, please reach out, and we'll be happy to help. So with that, with a JIT state client, Verkle, and the proposer-builder separation, we'll be well on our way towards a lightweight staking future. So that's it for now, and I think we have maybe a minute for questions. Great, thank you.
Yeah, we do. Are there any questions from the audience? So perfect.
Thank you very much. Not that I really understood most of the detail that you were presenting, but just a very general question. As a staking operator, is it something that you expect everyone to move to save costs and to be more efficient when providing the services, or is it something that only specific operators will adopt in the future?
Yeah, we think there will be a lot of incentives to move for most stakers to move this direction. The big downside is if you do need close to instant random state access for some reason, or if it's important to you to be your own block builder, those would be two reasons why you wouldn't move this direction.
Any other questions from the audience here?
Yep. So right now the consensus layer is pretty sensitive to this. Like how could this impact like the performance of a validator running on a less client, based that now like the latency is getting even shorter? Like we're talking about not 12 seconds to propose a block and send it, but 4. Like did impact? Right.
So the higher latency that I mentioned before about sort of on-demand state access often would sort of make it impossible to do your staking duties. That's why it's important that everything that you do as the staker in your slot or a verifying block, that has to be done statelessly. So that's why Verkle's a hard requirement for this path. Introduce latency there without causing problems. So yeah, I think you have the right.
Excellent. Well, Jason, Danielle, thank you very much for an excellent presentation.
Yeah, thanks. Thank you.
Okay, well, we're going to continue on with today's programming here. I'm very pleased to end here, who is the head of protocol engineering with ChainSafe, and he's going to be speaking to us about our new favorite testnet.
Thank you, Ken. Yeah, good morning, everyone. I'm not only head of protocol at ChainSafe, but I also do testnets on the side, and I want to give a presentation today about a new and upcoming testnet that might catch your attention. What is a testnet? So the non-technical explanation is if you have a lot of ETH and you want to test out a new smart contract, you don't send all your ETH to it and just YOLO, you don't want to, but you test it, you set a small amount, see if it works before you go in with a full thing. So in software engineering, you do the same thing. If you build software, you don't want to test it in production, right? You want to test it before. In blockchain systems, Ethereum, we are talking about massive peer-to-peer networks, and in network engineering, we need to also test networks, right? That's what a testnet is. And today I'm talking about a very specific kind of testnets, which are the public testnets or stable testnets that are used by a lot of different users to test different use cases. Who are these users? The users couldn't be more different in what they require from a testnet, what they do on a testnet, and what they want to achieve. There are the protocol engineers that build the lowest layer, the actual testnet itself, or the actual execution layer, the actual consensus layer in the case of Ethereum. There are huge service providers. There's a huge amount of contract and application developers that build on top of this entire stack. And obviously there are all the people engaging in consensus. In case of Ethereum, it's the stakers or staking pools. And last but not least, the users actually engaging with all these different layers of the testnet. So what are the Ethereum testnets? You've probably known them for a long time. There's Gurley, a proof of stake testnet. There's Sepolier, a proof of authority testnet. And
you might not have heard about Holeshki yet, but I get into this a bit later. It's also a proof of stake testnet. But what's the difference? And why is there a difference? Proof of stake obviously is like mainnet, so you know, most of you probably stake ETH on mainnet, but if you do so, you might, unless you use a pool where you really trust it, you might want to test your setup before doing that. And you can only do this if we actually have a testnet as also like mainnet, so supporting the full-blown proof of stake. And this is valuable for mainly two groups of users. First of all, for protocol engineers that want to make sure that their algorithm, their beacon chain, the consensus layer is actually working. And also, obviously, for everyone who wants to stake ETH. On the other hand, proof of authority has been very valuable in the past to provide testnets with a certain stability guarantee. So if you want to build applications on a testnet, you don't necessarily care about if it's proof of stake, proof of authority, proof of work or whatever, or even mocked consensus, you don't care. You just want to make sure that the application you test, and eventually if you have a larger stake, you provide it to your users that want to test it. So you want to make sure it's also available and stable throughout a long period of time. So this is mainly valuable for application engineers. So when we just launched the Holeshki testnet, the question was raised, why do we need a new testnet? We already have two or even more. So let me just take a look at the motivation here. So the Gurley testnet, which is our current proof of stake testnet, it has been deprecated earlier this year. It might reach end of life. It's not really officially announced, but we are very close to end of life. And the main reason is that we are out of testnet Ether. It's simple as that. You know, if you don't have Ether to test, you cannot run an application on it, right? You cannot interact with smart contracts, but most importantly, you can also not test staking, right? The entire operations of staking, you know, each staker needs 32 ETH, and if you have a pool or a larger stack of, you want to test a fleet of stakers, you easily need 10,000 of testnet Ether to test your setup. And since the Gurley testnet Ether distribution is basically depleted, this created a very horrible situation of speculation. So people that didn't get testnet Ether started to try to buy it on shady channels. So there was a speculation around this asset which should be free for everyone to use. So there was a decision made, we need to like really purge this and just replace it. On top of that, we also need a better testnet because Gurley was always lagging behind a bit. So protocol engineers ideated what is actually the requirement for a new testnet and what can we do? Can we use this chance if we launch a new testnet to get ahead of mainnet? Oh, and last but not least, this would be the first testnet we launch after the merge last year. So we can actually bake in the merge to proof of stake into Genesis. So we have a proof of stake chain right from Genesis, which is, I believe, really exciting. This is EF DevOps team and myself at Protocol Berg in Berlin trying to launch it. We didn't manage to, but we launched it later, relaunched it later. Yeah, so why is this important, what I just said? So for protocol engineers, the idea to have, especially for the consensus layer engineers, to have the idea to be ahead of mainnet, this basically means to have more validators on a testnet than we actually have on mainnet. So you can see on Gurley we have currently 600,000 validators. On mainnet we have around 1 million, whereas we launched Holeshki with 1.5 million. And this serves like a canary. You know, if something goes wrong, we want to see it on a testnet first and not on mainnet. And if mainnet is ahead of a testnet, there is actually the possibility that we would spot bugs on mainnet first, which is not desired. So we decided to use this opportunity to go ahead of mainnet. Also, in addition to that, we drastically increased the total circulating supply. The circulating supply for the testnet. We baked in almost 3 billion Holeshki Ether into the Genesis, as compared to what the laughable 100 million we launched Girly with. Also, we came up with some strategies of distributing the Ether to users of the testnet. So we pre-funded 500,000 wallets with 1,000 testnet Ether on Holeshki. So if before you complain on social media about getting testnet Ether, check your wallet first. Shout out to Philip, who did the heavy lifting there. And also we distributed a lot of testnet Ether to important stakeholders in the ecosystem, like ETHStaker, that run their own services to distribute testnet Ether and ETH-staking or testing. Yeah. So I think we just told everyone last year to migrate to Girly, which was either a miscommunication or a lack of communication. I think we were not entirely sure what a strategy for testnets would be, and as I said, there are so many different stakeholders in the ecosystem, and many people have different ideas about testnets or about stability guarantees. And when we told people last year to migrate to Girly, we didn't really think this through. We have to admit this, and that's the moment where we started, too late admittedly, but we started to talk about strategies out of this mess. So a lot of so if you have a large application stack, like, I don't know, you run a huge system of contracts that depend on each other, you need a network effect of integrating with other applications on testnet, or even run a layer 2, it's a huge stack you deploy on a testnet, and then someone tells you now deploy it on another testnet. So a lot of projects were not happy about this. So we thought, how can we manage expectations for testnet, and came up with a predictable testnet lifecycle that has clear timelines and predictable end-of-life expectations, so that migration paths can be planned long ahead of deprecation, so that projects are kind of aware that a certain testnet comes with a certain uptime guarantee. And the idea here is to have a guaranteed testnet lifetime of 4 years, and allowing on top of that maybe long-term support, or if a testnet does well, we don't necessarily need to deprecate it after 4 years, but we don't really want to commit to more than 4 years here. And since we have both a proof of stake and a proof of authority in testnet, we will launch a new testnet every other year if we commit to this plan. The actual proposal we wrote is on Ethereum Magicians. You can look it up, and this timeline just visualizes where we are right now. You can see 2023, Girly is at the end of life. Sepolia is in the middle now. Most of the applications are migrating to Sepolia currently. If you did not migrate yet, you might even consider another option now. So, yeah. We also shut down Ringby earlier this year, so it's a lot of movement in the testnet landscape. Girly is, I don't know what the exact date will be, but it's about to die. I think we still have to officially announce the Holeshki launch. But at this point, I would say if you still run Girly or Ringby or any other testnet, it's really time to consider migrating to Sepolia or Holeshki, depending on your needs. Okay, I'll finish my presentation with a handy testnet selection guide. As I said, Holeshki is proof of stake, so obviously if you're a staker and annoyed about the Girly stack, just take a look at Holeshki. Due to the size and expected network effects, it could be also interesting for large service providers or layer 2s, or really whoever else needs mainnet conditions on a testnet. At the time of this presentation, the expected uptime guarantees are around 4 years, with an end of life of 2028 for Holešky. Sepolier is, as I said, for whoever needs stability guarantees, mainly application developers. And currently the expected lifetime is another 2 years for this testnet. Repeating the obvious, don't use Girly. Please stop using Girly. Painful for me to say this. Girly was a really important project for us when we launched it 5 years ago. But testnets changed a lot since, also Ethereum changed a lot since, so let's officially deprecate it, stop using it. Obviously also don't use Ringby, Rubston or Cohen. And if you didn't listen to me the last 10 minutes, this is the summary. If you want to stake, use Holešky. If you want to test application stacks, use Sepolier. I have a bonus slide, since I have time. How to get testnet Ether. It's a hot topic, has always been. Obviously for Holešky, check your testnet wallet. We did this airdrop to 500,000 wallets on Holešky. So yeah, that's the first thing you should do. Obviously, we have nice faucets up. My favorite is the proof of work faucet by Philip. But there are also others. If you want to validate and don't have enough Ether to test the validator setup, obviously eStaker is doing a really good job at distributing or funding your validators directly. You can use their launchpad. ChainSafe provides a similar thing. It's called the validator faucet, so you don't need Ether, but you can still make deposits and run your own validators with their ease. And in case you didn't know, if you have tickets on Zupass, you can also claim testnet Ether. So you can go to the Holešky faucet pk910.de and connect your Zupass account. And you will be eligible to get 500 testnet Ether. I think on every network, but yeah, you can check it out. And that's plenty if you want to test staking setups or applications, so you should be sorted up for a while. Yeah, and last but not least, if you really have a reason for a huge amount of testnet Ether, you can always talk to your local dealers, if you know any. That's my talk. Is there any question?
Oh, perfect, excellent questions. We'll get right to them.
Thanks for the talk. Yeah, just a quick question regarding how much is the fish. Maybe you talked a little bit about it in the beginning, but I missed it. Can you tell us what exactly went wrong with the first testnet launch and how it's related to the fish?
Thank you. This is my favorite question. We have been launching testnets for a while, and I personally believe it's a beautiful moment to launch a testnet because you create a Genesis block by hand, and you can like put up a lot of things that remain in the history forever. You know, it will be always in the extra data of block 0, for example. And for Holešky, we viewed the Genesis block. I set thing in there and just put the example how much is a fish, and the person who was authoring this pull request took it literal and put in how much is the fish, which is kind of funny today. But then it was yeah, it was funny all the way, and it didn't realize by completely broke the entire testing set, or like the way because all these files were pre-generated. If you change something, you can no longer be sure that everything else is fine. So what happened is that we patched the genesis of the execution layer manually without updating the consensus layer. Once we launched Testnet at Protocol Berlin, we managed, so the consensus layer just refused to talk to the execution layer because they refused the genesis, and what we had to do is basically just remove this again and launch it. So it was not a big deal, but it was kind of sad, but also now I think now we can laugh about it.
Hi, Afri. Since you mentioned the situation with Gurley, the speculation with Testnet Ether, I wonder if there is any solution or any plans to avoid this same situation in Holesky.
Yeah, and that's also a very good question. So there are a lot of things you can do about this. So first of all, you can increase this thing, because if you have more, obviously that will last longer. Then also what eStaker does or what ChainSafe does with the validator faucet, you put out the Ether for the people testing, but you basically make them to set a withdrawal address to their account. So whenever they are done testing, it basically goes back to you. So it stays in circulation, and it's not just because people lose interest or move on, they will not just, it's not getting lost, right? And there are many of these ideas. And last but not least, we have, on Holeshki, we have these mechanisms, but since Sepolia is proof of authority, we have a way to mint new tokens through the deposit contract. So we have technically an unlimited supply there. Ever in a situation, I think we should be good for at least 5 years. And just looking at how long we managed to deal with Gurley in the last 5 years with just 100 million total supply, I'm very confident we are set up for future here.
Yeah, I have a last question. What stability guarantees does proof of authority offer?
Sorry, can you repeat this?
Yeah. You said that proof of authority offers more stability guarantees. What are they? Can you comment a little bit more?
Yeah. So before the merge, proof of authority has basically, you just have 7 validators that run the entire consensus for the chain, and if someone goes down, write one message on, I don't know, Matrix, and then ping this operator, and this person will respond within a couple of hours, and then it's fixed. So the network is not relying on a large amount of people or organizations to coordinate to stake, but just a couple of few. So after the merge, the Sepolia testnet is run by, let's say, 15 or 20 entities that coordinate in a chat channel, and it's a closed validator set, so nobody data set. So the stability guarantee here is like on the consensus side, right? And all other stability guarantees are inherited from the mainnet. I think that's the difference.
One more question in the back here, and
I'm just wondering if you can talk briefly about performance. And one of the things that was annoying about testing validators on Gurley was that you'd miss attestations sometimes, and it wasn't necessarily your fault because the whole network is just not performing as well as mainnet. Do you think that over time Holesky will start to look like that as people are done testing and they just unplug their machines and don't properly exit their validators? Is there any reason that Holesky will be any better performance-wise?
Yeah, I think it's just getting worse the bigger the validator set is, but what we did is we tried to ensure that, let me say, trusted operators have a super majority in this validator set. So it's a lot of all the client teams, Ethereum Foundation, long-term community members are running a huge chunk of these validators to just make sure certain finality guarantees for the testnet, but still keeping it open for everyone else who wants to join. So Gurley was a bit shaky at some point, and we cannot rule out that this will not also happen on Holeshki at some day, but it is
it is the of stake on a zero value testnet. We cannot fully mitigate this, unfortunately.
Well, excellent. Thank you very much for a wonderful present, giving our speaker a round of applause here.
Thank you.
All right. I'm very pleased to introduce you to Michael Sproul. Michael is a developer with the Lighthouse client, Sigma Prime, and he's going to give our next presentation.
Hi, everyone. Thank you for having me. Yeah, today I'm not going to be talking about Lighthouse, but another project of ours called Blockprint. And this is a project for measuring client diversity on the consensus layer. And I've never actually given a talk about it, so I thought this would be a good opportunity to sort of look back on the last 2 years of client diversity history and Blockprint, and sort of what we've been working on and how that's going. So client diversity is this idea that probably many of you are already familiar with, that we don't want a bug in any single client to cause damage to the network. So ideally, on the consensus layer, we have 5, 6, maybe soon 7 clients or something. And we want the split between these clients to be sort of equitable enough that no single client has like 2/3 of the stake. Because if a single client has 2/3 and then there's a bug in that client, they can like finalize an invalid chain. And if this happens, it's like doomsday, basically. Like the validators that are running that client probably lose all of their ETH. It's really bad. So 2/3 is like the death threshold, and then 1/3 is like kind of bad because then they can stop liveness. So liveness is like being able to guarantee finality going forward. So, pardon me, we need about, 1/3 per client max is the real limit, and 2/3 is sort of real danger territory. So 2 years ago when I started working on Blockprint, the situation was basically that we had these network crawlers for looking at the consensus clients and seeing what they were running. And how these crawlers work is they basically just go around the peer-to-peer network connecting to nodes and then saying, hey, what client are you running? And the nodes mostly respond honestly because that's the default behavior. Like if you haven't hacked your client, it's going to respond honestly and say, yeah, hey, I'm running Lighthouse. So from these metrics, which are still very important, you get a sort of view of the nodes on the network, but you don't get a view of what the validators are doing. So you don't know how many validators are running on each node. You might see, okay, there's a split between Lighthouse, Prism, Teku, Nimbus, but you don't know that there might be like 200,000 validators or something crazy running on a single node. So for the purposes of client diversity in the consensus layer, the thing that's really important is the number of validators. So these network crawlers are still very important, and they are still running today. And they also give us this sense of like geographic diversity, which is also important, because if there's a network outage in the US or something, we want the chain to be able to sort of limp along with the rest of everyone else around the world. So this was the sort of status quo as of September 2021. And we thought this was pretty good, but it turned out we could do a little bit better with Blockprint. So Blockprint was born out of some other analysis that I was doing. I was looking at how the consensus clients were building blocks on mainnet because I wanted to understand the profitability of the block building process and whether clients were including redundant attestations, whether they were being as efficient as possible when there were like skipped slots. Ooh, sorry. So I was looking at all this data and I basically had a big Google spreadsheet of data about the different clients. And what I noticed was that there were certain patterns between the clients as to how they were doing things. So each client basically has a characteristic fingerprint. And for the first version, I basically just like eyeballed what the fingerprint was, and I wrote this if condition that's like 5 lines. And this is really, really dodgy, but it mostly works. Like it gives this graph, which turned out to be pretty much accurate. So this is the client diversity. Okay, we're back. Sorry. This is the client diversity on mainnet as of September 2021. So this was when I first came up with my estimate. And you can see there that we're really close to the danger threshold for PRISM. It's at 64.8. But with the caveat that we didn't really know how accurate this was. But this was like a rough inkling. We could see from the network metrics that PRISM was big, and then this sort of confirmed that, yeah, okay, PRISM's really big, and the other clients are sitting there at barely above a third, all combined. So this first version, as I said, was a bit dodgy. It was like my expert knowledge that was sort of encoded in this program that manually looked at various things. In AI, this is considered sort of quite bad practice to be relying on like sort of expert input to build your system. It's much better to have something that learns and works out what the pattern is itself. And we didn't really know how accurate this system was, as I said. So we were sort of flying blind, but I tweeted this thing out, you know, in September, and everyone took my word for it. And then I felt like I had to then develop that a bit more and make it more accurate and actually really prove to myself that this was valid. So with this in mind, we dedicated some time to building a sort of 1.0 version of Blockprint that was a little less dodgy. And so we took an off-the-shelf machine learning library in Python called scikit-learn, and it has a implementation of a k-nearest neighbors classifier, which is very much what we want to do. How this classifier works, you can see there, it sort of plots the training data in an n-dimensional space, in this case 3-dimensional. And then when you get a new block in, what it does is it will just measure where that block is in the coordinate space and take the 5 closest or the 7 closest points and work out what the block is likely to be based on that. So you can see, I'll go into what the axes mean in a minute, but you can see there's sort of a clustering of purple and a clustering of pink, which are Nimbus and Prism. Lighthouse is sort of concentrated up the central axis, and then there's Teku in grey is over sort of near Nimbus, which is why they were getting confused in the initial version. They looked quite similar to the machine learning model. And then on those axes there, these are like various properties of the blocks. So when we fingerprint the block, we use a little bit of expert knowledge to like pull out some numeric value that represents something about the block. So the z-axis, the vertical one, is like a measurement of the block reward. So you can see that at the time when this happened, Lighthouse was doing well for block rewards, which I was very proud of, and it was sort of a bit of an outlier on that z-axis. So that would sort of flag that something was Lighthouse. The x-axis across horizontally was the redundant attestations. Ideally, clients shouldn't have been including redundant attestations, but due to various quirks of their algorithms, some of them were. They're not doing that so much anymore, but occasionally. And then the other axis was about the ordering, because attestations are often ordered from most profitable to least. So we were looking for, okay, is this client being very strict about how it orders the attestations in its blocks, or is it being more loose and using some other algorithm? Yeah, so this first version was a lot better than the very alpha spreadsheet version. We collected training data based on graffiti. So we had a big collection of Lighthouse blocks, Prism blocks, Teku, etc. We could configure the features, which are those axes that we were using, and find out which ones were the most effective. And for measuring accuracy, we had a nice system of cross-validation, which is a standard machine learning thing where you keep a portion of your training data aside, you train the model on the rest of the data, and then you measure it, how accurate it is on the remaining portion, and you go, okay, did I get that right? And you get a sort of percentage value of, oh yeah, okay, you're 95% accurate or something. Often not 95%, but these are the features. I maybe won't go into this too much because they're kind of, there's a bit of, this is like getting into the weeds, but you can see that we've got a bunch of features. These are just metrics, like, you know, you take the block, you analyze it, you pull out a number. So the percentage of the attestations that are redundant is one example. How sorted the rewards are from profitable to least profitable is often the ordering. Some clients also sort by the slot of the attestation. If they're including old attestations, sometimes they'll put them at the end or sometimes they'll put them at the start. And a few other things like the number of single bit attestations, which is like unaggregated attestations from a single validator. Sometimes that turns out not to be a very good feature, but it was something that we tried. So using this new 1.0 model, we blazed ahead. I kept tweeting these things out every couple of months. People would ask me, oh, how's the client diversity looking? Is it better? Is it better? Is it better? And I was basically like, no, it's not better. So in January 2022, which is really not that long ago, we were still sitting at Prism around 2/3 of the network, which is, it actually in this graph crossed the danger threshold. So people were really starting to get worried at this point that if there were a bug in Prism, it could really bring the network to its knees, and that would not be good. So off the back of this, there was a really strong sort of social coordination campaign to improve the client diversity on the chain. And there were various websites. The top one there is now defunct, but we in Viz from, I think, where does he work now? Beacon Chain, did some really good stats on what clients the staking pools were using our data. And then clientdiversity.org was showing the total network breakdown. Some of the staking pools produced reports about what clients they were using, and then sort of pinky promised that they would diversify, and then they did diversify, which was good. Lots of tweets, lots of community leaders. People probably in this room were helping lead the charge against that, which was good. And the Prism team were very gracious and also started to promote this idea of client diversity and getting people to use other clients, because for them, even though it's a sign of their success and obviously a testament to the great engineering they're doing, it's really not what you want to be the developer of the majority client, because it puts a lot of stress and pressure on you. And we've seen this with Geth as well on the execution side. It's a really high stakes thing to be working on this majority client, and like, you don't want to make a mistake when you're doing that. It's much more like robust and relaxing for you as a developer if there's someone that shares the load with you, and you can not make mistakes, but like, if you do make a mistake, it's not the end of the world. And yeah, this campaign worked. So this is the client diversity as of today on the consensus layer. You can still see Prism and Lighthouse are over the 1/3 threshold. So we still have a bit of work to do. We could ideally spread out another 10 to 15% of the stake. I actually suspect that this will improve at the next Deneb hard fork, because there are some changes to how blocks are built, and I think Nimbus will probably bump up, because Nimbus's blocks are generally very profitable, and I think people running multi-validator setups will probably start producing more Nimbus blocks, and we'll see that in the stats. But yeah, we're doing a lot better than we were, and we're no longer close to that dangerous 2/3 threshold. For a while, Lighthouse was above Prism, and we were worried that it might get to the 2/3 threshold, but thankfully, Prism has like risen back to the top, and we're not close to 60% or anything, so it's all good. Yeah, now I'm just going to talk a bit about the development that we've been doing on Blockprint since then. Because we realized this was quite an important piece of infrastructure, we really wanted to get it as robust as possible, make it as accurate as possible, and keep building it out. So some of the features we've been working on, we've got an API for researchers to use. It turns out this data is quite useful and quite interesting for doing analytics of the beacon chain. We've also improved our accuracy monitoring so that it happens live. we're looking at rolling out the model so that it supports more clients. In particular, Lodestar and Grandine are not really properly accounted for in our current model, but we're working on that. And we're also trying to onboard more developers and more infrastructure operators to sort of grow the ecosystem, get more people involved, and then really make this a core part of Ethereum's diversity infrastructure, which is cool. It also means less work for me, hopefully. Yeah, so the Blockprint API, we have to strike a balance here between producing useful data and also preserving privacy for the validators that are being sort of exposed by our fingerprinting. The risk here is that if you know what client somebody is running, you can potentially target them with a vulnerability that's specific to their client. So at the moment, the compromise we've got is that there's an API that gives aggregate data, so data about the whole validator set, but if you want data about specific validators, then you need to DM me and ask for a password. And this is, I don't know, it's not very open, but the code is all open source, but getting access to our instance is permissioned. So it's sort of this middle ground between being open and being private. Some of the apps that have been built with the private API are really, really cool. This one, reorg.pix by Tony, who you'll probably see later today. It's really cool. It shows the number of reorgs happening over time. You can actually see there's a big uptick recently, which is a bit concerning. And you can see the breakdown by client. So you can see that actually Lighthouse, which is my responsibility, is there getting reorged quite a lot. And that's something that we're aware of and working on. But having this dashboard is really invaluable because it means we can see that this is happening and address it. Another one, and I only added this slide this morning, so I'm glad it's here, is the EF DevOps guys have built this cool dashboard. It looks a bit washed out there, but it basically shows the number of online attesters classified by their client and also the number of offline attesters classified by their client. So the top one is the online one. You can see it's basically flat over time. This is just a short time period, so we don't see any changes. But we can see that the offline attesters, there's a few blips here, the orange line being Prism. That's probably just a couple of staking pools or something that had an infrastructure issue, went offline briefly, and then came back online. And you can see the y-axis is just like a couple hundred validators, so it's not a big issue. But if there was some bug that knocked a bunch of validators offline using a particular client, we'd be able to see that show up in this graph. So this is like a private dashboard at the moment, but the EF DevOps people are monitoring this and will raise the alarm, I'm sure, if something goes wrong here. So and then the other main work stream that has been part of Blockprint is improving the accuracy over time and improving the monitoring. So we need to do this because the clients are constantly improving. They're changing how they build blocks, and that could change their fingerprint. In Lighthouse, we're about to change our fingerprint slightly. And the other thing is that doing the cross-validation that I mentioned before, that was just something we had to do manually. It's much better if we can do something continuously over time. And the final point is that we were previously limited by the graffiti to get training data. So this is fine for most of the clients, but Prism doesn't actually use any graffiti by default. So Prism was kind of actually underrepresented in our training data because it was hard to find enough blocks that were made by Prism. And the way we've addressed this is this kind of complicated system that builds blocks continuously and measures how well they're being classified. So I'm going to show you a horrible diagram now, but then I promise I'll explain it in smaller pieces. So this is the system that we came up with. You can follow these steps in sequence, but basically there's a thing that produces blocks using a bunch of different clients. So I've got this cluster that runs 2 of every client. It's like Noah's Ark. And then it feeds these blocks into Blockprint, and it says, hey, Blockprint, did you get that right? And then it keeps track of whether Blockprint classified them correctly. So we produce a block using Nimbus, we feed it into Blockprint. Blockprint says, hey, that looks like Prism to me, and we go, naughty Blockprint, that was wrong, and we write that down. A key part of this is that we have an execution multiplexer. I kind of wrote this for fun. I kind of wrote this to save on infrastructure costs, but it just allows us to connect multiple consensus clients to a single execution client, which is something that since the merge has not been possible. It used to be possible to sort of share an execution client, but since the merge it's been one-to-one. And this now makes it so you can have many-to-one. And there are other multiplexers that do one-to-many. I think Nimbus natively supports one-to-many. But the important part of this for us is that it also takes care of building the execution payloads, because we don't necessarily want to go to the execution client and force it to build a valid payload with all these transactions that we don't really look at anyway. And that takes time and effort. The other part, so the next part is the thing that actually builds the blocks, or actually requests the blocks. This is called Blockdreamer, and it goes just via the HTTP API to all of the clients that are in your cluster and says, hey, give me a block, give me a block, give me a block, give me a block. And then those consensus clients go to the multiplexer, Electric Eel, and they say, hey, give me a payload. It gives them a dummy payload. And then Blockdreamer gets all of these blocks from all the different clients that it can do stuff with. And what does it do with them? It sends them to this other microservice called Block Gauge. And this is the part, this is the real, where the magic happens. It sends those blocks to Lighthouse to convert them into the form that Blockprint wants, and then it sends that data to Blockprint and classifies the blocks. So this is where if Blockdreamer produced a block using Nimbus, it sends it to Block Gauge sends it to Blockprint, and Blockprint hopefully says, yeah, that's Nimbus, or it might say something else. And then we keep track of the true positives, the false negatives, etc., inside of Block Gauge. We've built also a nice user interface. So this is a web UI that you can access now at blockprint.sigp.io. And I'm very grateful to my colleagues who have front-end design skills for building this for us. It looks really cool, I think. And we show the same sort of breakdown as clientdiversity.org. We are very open about taking inspiration from that website for this graph. And then we also have a nice table of numbers, which is very exciting to look at if you know what these numbers mean. Oh, the red ones are very hard to see, but I'll go into briefly what this means. Am I doing for time? Yeah, okay. So one of the main things that we measure for our model is the true positive rate. And this is sort of like a statistical property of any diagnostic test. It gets used a lot in like medicine, actually. Like if you do a COVID test, it has like a guaranteed true positive rate, which is kind of cool. So here we're looking at, for each client, these are the ones in the rows, we say, okay, of all the blocks produced by that client in our cluster, what percentage of them did you classify correctly, Blockprint? So if you look at Lighthouse there, you can see of all the Lighthouse blocks produced, 0% were classified as Grandine, which is good. 98 or 96% were classified as Lighthouse, and then 0% were Lodestar, 3% were classified as Nimbus, which is a little bit of an error, but not too bad, and 0% as Prism, 0% as Teku. And you can see this table, the true positive rates for all of our clients are pretty good, except for Grandine and Lodestar, because they're actually disabled in the model, so there's no way for it to get them right. They're always classified incorrectly, unfortunately. But we're working on that. More on that soon. The other like statistical measure that we keep track of is the positive predictive value, and this one is like a little less intuitive than the true positive rate. And I think the first time you hear about this, you're going to be confused. Probably, I was confused for a long time, but it basically sort of flips the framing and says, okay, of all the things that are classified as Lighthouse, what percentage of those were actually from Lighthouse? So it's like this sort of you've switched around some of the numbers in the calculation. And this one turns out to be very sensitive to things being classified incorrectly, because we've got a lot of Grandine blocks getting incorrectly classified as Lighthouse. Lighthouse's positive predictive value is actually really low, but it's sort of artificially low because we know that it's mostly Lighthouse blocks that are in there, but there's a lot of false positives from Grandine. So I think once we get Grandine and Lodestar sorted out, this graph will actually look quite good. You can see that the bottom row for Teku is like 98%. And yeah, ideally we'll have all of the clients around that like 95% plus level, which is really good. Yeah, so the minority clients, this is kind of like something that I've been trying to deal with for a long time, but we don't quite have a perfect solution yet. The problem is, even if you have like a 99% accurate test, you're still going to get 1% false positives. And this is a thing called the base rate fallacy that's like common in statistics. So yeah, if you have 1% of a million validators, that's like a lot of validators, right? And this could be larger than the client's actual share, which means that if you see something classified as Lodestar, it's like 50-50 whether it was actually Lodestar. So we're not really doing, it means that like if we're guessing, if we're like the positive predictive value ends up being like 50%. If something was classified as Lodestar, it's like 50-50 whether it was actually Lodestar. And it throws off the accuracy for the other clients as well, which is a bit frustrating. But our hope is that by getting enough synthetic blocks out of our cluster, we're able to build like bigger models that are really, really accurate for all the different clients and find features that discriminate between the clients. And then once we've built this model and tuned it with all 6 clients, or all 7 clients, however many there end up being, then we'll redeploy it and continue monitoring it with all of this infrastructure that we've built. So I think we're much better set up now to continue growing into the future, which is exactly what we need. And then this is the final thing we've been working on is sort of opening up Blockprint's development and its sort of organizational structure. We're just starting a collaboration now with Mega Labs, who have done a lot of work on beacon chain health and also have their own network crawler. They're now running their own instance of Blockprint. They're going to help with the development, and we're going to share training data, models. We're going to share some of the clusters for nodes that are building blocks. And yeah, I think this is really cool. And we may also onboard more people in the space, maybe get some Blockprint instances running on Testnets, get one on Holeshki, maybe even on Gnosis Chain, which uses the same clients. And yeah, just basically building out the infrastructure and making sure that it's really solid into the future. Thank you very much for listening to my talk. Does anyone?
Are there any questions from the audience here? Oh, perfect. Yeah, we got a lot of people.
Well, okay. Do you have plans to spread the Blockprint on the execution layer clients as well?
At the moment, I don't have plans to do that, and part of the reason is that it's hard to fingerprint the execution clients because like 90% of blocks are built by block builders now. So you'd really probably just be fingerprinting the block builders, not the actual execution clients.
But don't they use the same client software to build blocks?
So the thing is, they use the same clients, but they don't use the same client as the proposed signing the block. So we'd be able to get a measure of what execution clients are used by builders, but we wouldn't get a measure of what execution clients are used by validators, which is what's more important.
Okay, Carol.
Yeah.
Thank you. Any other questions from the audience here? I guess I had just one quick one, maybe that similar comment. Have you thought about with the client teams adding a breadcrumb instead of trying a fingerprint that kind of uniquely identifies a signature, just asking for a field or a declaration? Yeah,
so we did sort of think about this approach. The reason we haven't taken that yet is that it tends to work quite well or explicit fingerprint. And the problem is that with an explicit fingerprint, it then becomes much easier to game. Like I wanted to have a program recently where they'd incentivize people for running Lodestar. And if it was just like put Lodestar in your graffiti, then without actually running Lodestar, where if it's like some complicated property of their fingerprint, then it's much harder to fake. So, but that would be an option if, if the fingerprinting stops working at some point, yeah.
Any other questions? All right. Oh, wait, one more here in the front here, please.
Thank you for your work. Are you collecting orphaned blocks? Because I saw you fingerprinting, or you're collecting statistics on organizations.
Yeah. So how the thing works at the moment is that we'll get just every block. So we've got a thing that's just monitoring blocks as they come in, and it just fingerprints them and then puts them in the database. And then if they get opened later, they're still in our database, so we still have stats on them. So yeah, it's only if there's a slashable block that we'll just have to choose. Yeah.
Thank you.
right, seeing no other questions, please give our speaker a round of applause here.
Thank you.
We do have a little bit break before the next one, but because it's right before lunch, I wonder if he's here, if we could just move him forward.
I'll see if I can.
Okay. Oh, you're the next speaker, right?
Yeah,
Oh, perfect. Okay, we'll have you go up and start.
No, I mean like I'll put the weight.
Do you want to?
Okay, there. I'll be there earlier just to plug.
Okay, but you want to start on time for your talk, or? Okay, okay. I'll let people know because there's a little bit. He ended early.
Yeah.
He did, but you're the last one before lunch. That's why I was thinking if you just go now, we could.
I thought I was going to be after the lunch.
No, yeah.
So we have.
Yeah, lunch is from 1 to 1:35. So I was saying, why don't you go now, even if it's early.
Okay, I just need like 5 minutes.
Okay, okay, okay. Okay, for those in the from the audience here, we're going to just take a short 5-minute break. Our next speaker is actually going to start early. That way we could have a longer lunch period. So we'll resume our last speaker before lunch in about 5 minutes. We're going to schedule to give us a longer lunch break.
Okay. So, what should I do here? Should I do anything there?
That's what it's showing on the screen there. Is that your other screen?
Oh yeah.
You might have to.
Yeah. Oh, that's.
You might have to just remove your second screen, or.
I have a second screen right now.
Yeah, and here. This here. Oh.
Yeah, maybe flag it out and plug in again.
Yeah.
Yeah. Okay. Let's try. Okay, so okay, let me try just one thing.
Do you have a different USB-C? Try yours. Remove the extended screen and just say duplicate screen. Extended display, change that to mirror. Right. Yeah, there we go. We're good.
Hey everyone.
Okay. Okay. Well, thank you very much for staying here, and thank you very much to our next presenter here for offering to speak earlier here so we could all enjoy a little bit longer lunch. So without much ado, let me introduce Miguel, who's going to talk about a new EIP that I'm not familiar with, and so I'm looking very much forward to this.
Thank you for the introduction. Hello everyone again. Form, which is a fancy term denoting the EIP-6110 Proposal, which is in one sentence can be said as an optimal way to deliver evaluations to the consensus layer. A quick reminder of how depositing is happening in the Ethereum network. A staker prepares deposit data, then it submits them to the deposit contract in a regular transaction on the execution layer where it's been processed. ETH1 bridge takes this data and put them into the beacon chain where this deposit data is being processed by and the new layer is created. So this proposal does not affect the deposit contract logic. It also does not affect the consensus layer logic, including the activation queue. So the huge activation queue that we observed recently would not be affected by this proposal if it were in place. So this proposal is mainly about the replacement of the ETH1 bridge. And a fair question to ask here would be, why do we want to replace the thing that already works? Yeah, and during the next slides we'll figure out why actually we should do this. Okay, so yeah, let's examine the design of the bridge a bit. So we should step back a bit to the pre-merge time. So what you see is the actually the outline of the mechanism that this is how the bridge basically worked before the merge. It is implemented as a proposer routing. Proposers submit ETH1 data into every beacon block that they propose. ETH1 data includes deposit tree root, deposit count and block hash, obtained from the proof of work block or from the execution layer block at a certain follow distance. Once proposers come to agreement on the ETH1 data, they start to include deposit data into the beacon chain, fetching them by JSON RPC API from the execution layer clients. That's basically how how the bridge looks like. And what happens with the bridge during the merge? Actually, nothing has happened. We still have this bridge in place, which maintains the same logic. But there is one major difference. It is that the bridge fetches data today that are already secured by the beacon chain. So it means that this bridge is entirely redundant. So we have the bridge, so what? First, what do we know about bridges? Bridges are insecure in general. I would like to emphasize that ETH1 bridge is probably the most secure bridge in the entire blockchain world because it's driven by thousands of nodes running a variety of client software with a rich client diversity. And yeah, even though this bridge has own issues. For instance, there is the design flaw that undermines the security of the core protocol. An adversary controlling a slightly less than half of validators in the network can basically induce validators from the deposits that were never submitted to the execution layer. Then these validators can be withdrawn, illegally printing a decent amount of ETH, or other nasty things can be done with them. But this issue is more on the theoretical side of things because it is really very, very unlikely that on the mainnet there will be a party that controls half of validators. Aside of theoretical, there was a practical issue. What you see on the slide is basically the incident happened about 6 months after the beacon chain launch. And this what you see is Prism client fails to propose blocks, causing a mass empty slots on the beacon chain mainnet. And the reason behind this failure was the bug in the deposit caching, which is a part of ETH1 bridge implementation in the Prism client, and I believe in other clients as well. Fortunately, finality was not affected that time, thanks to client diversity and thanks to Prismatic team who fixed this issue quite quickly. Also, bridges are complicated. The ETH1 data voting basically is quite complex mechanism, so its description, its specification is quite complicated. And what we see here is basically the issue appeared in one of the merge prototype devnets. Teku stopped, in this devnet, Teku stopped produce correct ETH1 votes, which actually prevented new deposits from being processed and new validators from being created. This issue never appeared on the mainnet because that devnet ran a completely different configuration than mainnet runs. But nevertheless, it highlights the potential bugs that caused by the engineering complexity of this construction, and also who knows what potential bugs we may still have today in the clients that can appear later on. Engineering complexity is not the only kind of complexity that is related to the bridge. Aside of that, there is a node operators complexity. Various situations where consensus layer client is failing to fetch deposit data from the execution layer client keeps occurring today, which is maybe especially annoying for home stakers who, when setting up their nodes, has to deal with something like that instead of just enjoying running their validators at home. This is like, I would like to say that this complexity comes from the reliance on the JSON RPC API, and different clients, different consensus layer clients use different JSON RPC API methods to request this deposit data. So it's like, it could be a misconfiguration, it could be an interop issue between the client and server implementations of the JSON RPC API. So but this issue occurs today, which is quite annoying. That was not the only complexity that operators are suffering from. There is also the data complexity. This is because the fetching the entire history of deposits is quite annoying and quite painful today, because it takes a lot of time. And thanks to Dreamer, who came up with the proposal of deposit contract snapshot, which basically allows for a consensus client to be bootstrapped with a snapshot of a deposit tree, instead of spending the time on fetching all the entire history of deposits. Yeah, but to my knowledge, not every consensus client actively uses these snapshots today. So some of them are still requesting historical deposits via JSON RPC API. Also, because of this historical data complexity, this deposit contract snapshot proposal is kind of a requirement. In the context of the bridge, it's kind of a requirement for blockchain data expiry proposals, like for FORS. So it's kind of like a requirement and on the critical path to that. There are requests from node operators just to disable deposit syncing entirely for non-validating nodes, because non-validating nodes does not basically need this data at all. And consensus layer client doesn't have this option yet. So yeah, bridges can be slow. I don't claim that every bridge is slow, but ETH1 bridge is slow. It takes 12 hours to deliver a deposit from the execution layer to the consensus layer. And in the current design, we basically can't do much about it. So reducing this number would undermine the security of the bridge, hence the entire protocol. So we would probably need to change the design of the bridge, but why would we want to change the design of the things that is already redundant? So we went through the complexity and security that might be or related to ETH1 bridge, and basically now let's talk about the solution. So the solution is simple. Let's just deprecate it. Let's just get rid of it. So how can we do this? So what we basically do, as I've mentioned previously, the beacon chain already secures the data, the deposit data, which means that it has a direct access to those data with kind of one problem. It can't ensure validity of deposit transactions, and it can't parse deposit transaction logs to extract deposit data. And what we do is basically defer these responsibilities to the execution layer clients. So execution layer clients becomes responsible of two things. During creating a block, during building a block, the execution layer client will have to scan through the transactions that are supposed to be included in the block in order to find those transactions that produce deposit data, parse these deposit data, and include them as a separate list into the same payload. When a node receives a block from the network, the execution layer client of this node will basically validate this deposit list, proving that this deposit list is correct with respect to the transactions included in this block. And after this validation passes, consensus layer client can take this deposit data and process them as it basically does today. So no security checks on the consensus layer side is required. The security check are happening on the execution layer side. It means that the deposits will be processed in the same block, where deposit transaction is included. So it's kind of instance processing of deposits. It benefits many participants of the Ethereum community all over the Ethereum network protocol, network stack. First of all, it addresses the design flaw in the core protocol, making deposits as secure as the core protocol is. It gets rid of the ETH1 bridge code from consensus layer client, significantly reducing the complexity of these clients. The new proposal does not rely on JSON RPC API, which means that node operators' complexity will also go away once this proposal lands the mainnet. And after all, it improves the deposit processing UX, cutting the time to process deposit roughly by 60 times, which is just nice. Yeah, of course, as other proposals, this proposal comes with its own complexity. There is a negligible chain data growth. It's roughly about 100 megabytes per year, which is actually nothing. It opens up a potential DOS vector. This is because an adversary, after this proposal is activated, an adversary will be able to include up to 1,000 deposits into one block, delaying the processing of this block by a second. This happens because processing of every deposit involves signature verification, which is computationally heavy operation. But this attack vector is kind of not considered as a sustainable because in order to make this, in order to induce such load, an adversary will have to spend quite high amount of value, which means that the potential outcomes of this attack for adversary are outweighed by the cost of this attack. There is also the execution layer client's complexity. As I mentioned, there will be a couple of responsibilities that execution layer clients will have to handle. But this feature, the implementation of this feature on the execution layer client side is kind of self-contained. It has high testability because it does not involve any networking stack stuff. It's just basically block creation and block processing, which can be pretty well tested, and once it tested in the clients and implemented, they would not require any attention onwards. There is also the CL client complexity, which is about managing the validator pub key cache. So after all, there is a transition period also. Why do we need transition period in this case is because of the huge follow distance that ETH1 breach has, which is about 12 hours. And once these on-chain deposits are activated, there will be a gap of not yet processed deposits, lasts for 12 hours worth of block space, and we'll have to wait for ETH1 bridge to cover this gap. But once this happens, the ETH1 bridge can be deactivated without any additional coordination. So it's like transition period is definitely a complexity. And consensus layer client and blockchain data services will have to support two machineries at the same time. But this is kind of like one-time complexity. We don't have to deal with it in the future once the transition is over. Now I want to talk a bit about of the 6110 status. The design and specification are pretty much solid. There is also consensus layer test vectors, which is nice. There is a working prototype built with Lighthouse and Bazu. During this prototype project, we ran multiple devnets. We testing the core logic, testing the transition period logic. Also, we were doing stress testing. There was a devnet producing blocks with about 800 deposits each. We were measuring the performance of clients under this load. Many thanks to everyone who made this project happen. I was really enjoying to being a part of it. This QR code would lead you to the detailed report of this project. Also, there is a low star implementation which is near to be finished. I also know that Taku is looking into implementing 6110, and I would like to encourage every other, especially execution layer client, to implement this feature. It could be a really nice project, really nice starting project for one of your external contributors or for a new member of your team, because it's like it has moderate complexity, and on the other side it goes deep into the block processing and block building stack, which is kind of nice. It does not have any networking specifics. So yeah, please consider this for the kind of like really good first project for everyone is coming to the team or starting to collaborate with it. Yeah, so this proposal is kind of like strict improvement to Ethereum network security and UX, which makes me personally pretty confident that eventually it will be on the mainnet. Just a matter of time. Yeah, thank you for your attention. I'm happy to answer questions.
Any questions from the audience here? Perfect.
So 6110
basically relies on all the consensus layers to have deposit snapshots enabled, implemented. Is that correct?
Sorry, say the first part
does
again.
EIP-6110 require all of
No.
the consensus layers to implement deposit snapshots?
Oh, no. Sorry if I messed that up. So, deposit contract snapshots is required for blockchain data expiry proposals like 4.4s. If the bridge will, if we retain the bridge, so we'll have to do something with the historical data. Produce, snapshot to bootstrap nodes, because this data will be expired, basically. But with 6110, you don't have to do anything about that. Actually 6110 makes no use for 881 for these deposit contracts EIP. Sorry, Dreamer.
Cool. It seems though that like 6110 would be for new deposits coming in. How would we get, if we're not using JSON RPC to get to plugs, how do we get the pre-existing for a newly syncing node? How are you getting the deposits, the existing deposits?
You don't have to get the historical deposits once this is activated and the gap is filled, because all those are already on the beacon chain. So they see because they need to propose new blocks. This is why they're doing this. If we replace the bridge with like on-chain deposits, they're required. So no JSON RPC API requests anymore will be needed. Yeah, I forgot to mention that it produces sometimes enormous amount of load on EL clients, which is really not good.
All right, any other questions from the audience here? Okay, well, again, a round of applause for our speaker, please.
Thank you.
That concludes our morning's program here. It is now time for lunch, which is just right outside the doors. We will resume back on schedule, which I believe is 1:35. Check my math on it, but back in the room at 1:35. one more minute here. Just there's a lot of people watching online on the stream, so. All right, good afternoon. Welcome back, everybody. We'll go ahead and get us started here with this afternoon's list of presentations and panelists. And leading us off first after lunch here is going to be Perry. Perry is a researcher with the Ethereum Foundation, and he's been testing a lot of the Ethereum updates.
Hey everyone, can you hear me? Perfect. So today I'm going to be talking about testing, how we've changed stuff since the merge, and how the testing stack looks today. To begin with, you might have realized a lot of things in the pipeline for Ethereum. So the question does come into play, how do you generalize testing? For example, how do you generalize it between Dencun and between Verkle? The simple answer is you don't. We tend to have a stack for each upgrade, along with some inherited generalized testing from the previous steps. A good example of this is you're going to have to look at the EIP, you're going to have to read what parts of the stack are being changed, and you're going to have to talk with client devs to figure out what they are worried about for the upgrade and try and address those problems first. For example, Peter has this really in-depth PR about how the transaction pool changes for blobs. We just went through, and everywhere where he had a concern or every single bullet point, we tried having something on the testing stack that addresses that bullet point. So what does testing look like today? What are we kind of covering? We're, of course, covering the current fork, that current upcoming fork, so Dencun. We work on a potential future fork, so Verkle. We're working on a couple of features that might show up as a future fork. So you might have seen Mikhail's talk earlier about deposits. So that's EIP-6110. So we have some testing for that. We have some testing for Whisk, which is helping with validator privacy. There's a couple of testing stacks that are helping client teams optimize their clients. So we have like a testnet running for Ethereum.js to try and figure out how SnapSync works for them. We work on Big Boy beacon chain tests to figure out how big the validator set is. And as you can see, there's very few things that are shared between these topics themselves, but the problems that were raised between all of the testing stacks were kind of general. So I'm going to go through what those problems are and how we solve them. So the first one was the setup toil. So testnets used to have a lot of redundant configs, extremely easy to break them, extremely difficult to set them up. It was also very time consuming to add tooling to any sort of testnet. And if I had set up stuff for one network and another one a month later, there was already a huge config drift. We hadn't built it in such a way that you could share updates between networks. So it depended really on who was working on what. So what we did was split everything into a lot of parts that make it way more easy to maintain. So we use Ansible for all of our testing, for the testnets at least. So all the bare bones logic, such as this is a Teku node and it needs to be run on that machine, or I need Genesis and Genesis files need to be moved to machine X. So kind of the bare bones logic itself was moved into Ansible collection general. And then concepts or components were moved into their own tools as well. So Genesis is something that every network is going to have to go through. So we simplified it and we have the Ethereum Genesis generator. So it's just very easy to configure, easy to toss in, and you can just use the output of that in the aforementioned bare bones logic tool. Similar to tooling, you would spend a decent amount of time configuring the tooling. So instead what we did was we switched to Kubernetes for tooling. So we have Helm charts. So there's a Helm chart that runs the block explorer, a Helm chart that runs the faucet, etc. And there's this cool concept called Git ops, which is what you see in Git is what gets deployed on a Kubernetes stack. So we use Argo CD for that. So Ansible generates the Git configs, you commit it to Git, and the tooling just shows up. which is perfect. You never have to really think about tooling. Of course, there's some friction. The first couple of months getting stuff working well was a challenge, but I feel like we've gotten really, really good at this now. And the next problem was, okay, we have all of these parts and all of these abstraction layers. How do you bring them together? GitHub has this feature called templates. So we're using that to create a template testnet. So that sets up the entire folder structure you need, all the same defaults you need, along with a README on what values you should change. And on the top right, there's a nice button that says use template, and then it'll clone it into a repository in whatever namespace you want, and that has everything you need to make Kubernetes work, everything you need to make the testnet work. It's kind of really a reduced set of changes to get everything up. The next one was, how do we keep explorers working? So explorers are really specialized pieces of software. Mainnet's getting bigger, mainnet gets harder to run, so explorers had to keep up. But the more they had to keep up, the harder it was for them to also support testing. And devnets are really weird dependencies. So a simple example is for Verkle. We need to have a lot of Verkle libraries. No realistic explorer is just going to import random libraries that they'd never use on mainnet onto their explorer. So we had to maintain a lot of forks. That got harder as time went by. So we had someone in the team write a lightweight, self-hostable, extremely fork-friendly explorer. We call it Dora. And that helped us. We could add a lot of features that we wanted into the explorer more easily, and for smaller scale devnets as well. There was also some toil in getting Docker images working. So every single client team has their own CI, but they have their own logic as to when they push, which architectures they push, and so on. A simple fix was to just host our own CI, so we build Docker images for every single client out there. Sometimes we add some debug tools, but if nothing else, they're at least debug tool friendly. And then we do them on hourly builds for branches that we track. And if we don't track the branch, you can also just trigger a manual build for whatever fork you want. The next one were forks was really hard to debug. So every node on the network has its own version of what the network looks like. And when there's an issue, you kind of need to understand how the node perceives the network. So we wrote a fork visualizer that uses the standard API. And then the fork view was also integrated into the Explorer. So now it's actually easy to figure out how forked the network is, and then it gives you a good starting off point to know what you need to debug and where you need to start. The next one is a bit of a bigger topic. The peer-to-peer layer in Ethereum was really hard to analyze. We didn't really have the tooling, and even if we did, it was built into custom code bases for the clients, or they had metrics, but the metrics aren't really standardized. It was hard. There was no real analysis pipeline. So what we did was the team built Zatu, which is a network monitoring, and added an analytics pipeline to that. So you have the entire suite you need to actually analyze the network. And what that looks like is a centralized server, so that's the Zatu server, collects events from various sentries, which are just lightweight instances that run alongside EL and CL. And it connects to the CL's event stream, annotates stuff, passes it on to the server. And then the server handles persistence, passing it on to the pipeline, and so on. We also have a discovery node that just kind of crawls the DHT and figures out what's going on in disk v4. And we have Mimicry, which is a tool that collects a lot of information about transactions. So an example might be that you want to know when a transaction was first seen on a network versus when it was included in the network. Depends on what your use case is, but at least we're collecting that kind of data to understand how the network behavior is. And then Canon is a client that backfills data so that it helps for historic users as well. We have a nice overview on the notes page, so have a look about that one. And we do run the stack, so we're running it on mainnet, Sepolia, Gurley, Holsky. We run it on all the blob devnets, at least the latest ones, so that gives us a really good insight into how the network is actually looking. And we can do overview graphs like this. It's a bit of a chaotic screen, I apologize for that, but you can have heat maps on when attestations are seen, heat maps on when the blocks are propagated. You can have a graph that tells you, oh, if there was one blob, the block took so long to propagate. If there were 6 blobs, it took X plus 100 milliseconds to propagate. And that gives you a lot of deep analytics into, okay, maybe there's some assumptions we made wrong, or worst case, it reinforces the assumptions that we did make. And the last one I want to talk about is that it was really hard to test changes quickly. Earlier, we needed to spin up a network, or you had to maintain verbose shell scripts. It was just extremely difficult to just test an update. So we switched to using local testing along with a tool called Kurtosis. So Kurtosis allows you to specify a config either in JSON or in YAML. So here's a JSON example for how you spin up a local network with 3 Nethermind as well as Lighthouse nodes. It handles Genesis for you. It handles everything that you really need. And because it's a testing suite, it does some smart things. You can change the slot time, and you can change when the fork happens. So within a matter of a few minutes, you can have a local network with every single CL and EL out there, and know if a fork is successful or will fail. And we often do this to sanity check stuff. And we've even added the MEV workflow, so you can have the entire relay infrastructure set up, and it can help with either local integration or to just sanity check things or make sure that your fork works well. And the nice part is that it supports both the Docker backend as well as the Kubernetes backend. So if you do want, you can point it at Kubernetes and get a more scalable setup with X nodes over certain regions. So it really, really helps us with testing rapid iterating changes before we put in the effort for a full-scale DevNet. And here's how the testing workflow kind of looks like today. It's not a comprehensive workflow, but at least it gives you an idea. You have the specs get released after a lot of work from researchers. The clients work on this in a fork or a branch. Parallelly, there's this testing tool called Hive. Hive is, you can think of it like you pass it an input and an output, and Hive asserts if it's, sets up the network and asserts if it's doing what it should be doing. So Hive gets updated, and because Hive is extremely powerful and we're already able to think of a lot of scenarios where clients might fail, we push all the client teams to first test on Hive. So everything that we can expect and can catch, we have caught at this step. And if we've done that, then we start using local testnets with Kurtosis. And that gives us a sanity check that, hey, if we spend half an hour, 2 hours setting up a network, it's not going to fail immediately. And then we can start our full-feature DevNets. And if you have noticed from the DevNets for Dencun versus the DevNets we used to have for the merge, they stopped outright failing anymore. And the reason is because we've pushed for a lot of changes upstream to catch all the bugs that we can upstream way faster than we earlier could. And whatever we can't catch there is what's being caught on DevNets now. That's great from a cost perspective, time perspective, from a lot of different ways. And once we're happy with DevNets, we typically tend to have a public testnet or one that's more announced and supported. So external parties, explorers, tools can start using it, start integrating it. And once that's working well, we tend to have this concept called shadow forks, where you fork a main network, but on the side, you don't affect the main network. And this helps us get metrics about how that fork would have potentially gone in your sidechain. And once we're happy with that, we tend to go for public testnets as well as mainnet shortly after. So that's roughly how that's going to look. And what kind of tests we run for the different layers of the stack, you have, depending on if it's EVM changes, then we rely heavily on fuzzing or on fuzz EVM and tools that compare how the EVM output looks between different clients. If it's peer-to-peer layer, we have chaos testing tools, we have DevNets that we run. If it's engine API based, we tend to do more static testing. If it's sync, then we tend to do sync tests, and so on and so on. We have a lot of tool sets for different layers of the stack. And here's kind of the question, where is Dencun today? We did have a small spec change that has been added not too long ago, and it's being implemented in all the clients. I think the spec change is partly caused by some of the outputs from the testing, partly caused by researchers thinking about the problems a lot more. And this is going to help us simplify a lot of things and make sure that Dencun is a lot more safe once it's hitting mainnet. once that spec change is implemented, we're going to be doing a public DevNet, so we'll have DevNet 12, and we'll have a lot of shadow forks. So we're looking to have bigger shadow forks this time, like a couple hundred nodes, and that'll give us a decent amount of time into how long a network takes to process. It'll give us a decent amount of information about basically everything that we would need to know before we can commit to public testnets. And once we're done with that, we're going to parallelly start forking public testnets. So we'll most likely suggest Gurley, Holsky, and Sepolia, and that'll give us information on how a really big network is going to behave with blobs in it. And in the last couple of months, we have two big tools that are interesting. So we have Blobber from Mario from the testing team. And this is an evil man-in-the-middle peer-to-peer layer tool that sits kind of between the validator as well as the beacon node. And the Blobber decides which part of the network gets honest messages and which part of the network gets malicious messages. And this is a really, really interesting way. You can create a lot of scenarios which we didn't earlier have the capability to create. And the second one is AttackNet. So this is using a chaos testing framework. We're using Chaos Mesh, and it's a collaboration between like Trail of Bits, EF DevOps, and Kurtosis. And this would allow us to push the network on different layers of the Linux stack. So you can mess with the network latency, you can mess with packet drop, you can mess with CPU faults, RAM faults, you can add latency to the read and write from the disk. You can do a lot of things here. And we just started using this tool, so hopefully we're not finding anything too big, but it's going to be interesting over the next couple of weeks at least while we parallelly go ahead with Dencun. And what does Dencun mean for the home staker is always a big question. So based on the last couple of DevNets, it looks like there's only going to be a marginal increase in CPU and RAM. It doesn't seem like there's a big one, so you don't have to worry about going out and getting a new machine for supporting Dencun. There is an increase in disk use, roughly 50 to 100 gigs. It really depends on the values that we choose for the network, and that's what we're focusing on a lot of testing over the next couple of months to figure out those values. There is an increase in network use, so you can imagine roughly 100 kilobytes per second up and down increase. So yeah, there is some amount of spiky behavior in this, so it depends if there's suddenly a lot of transactions that get added to the mempool, then you have to go fetch them from your network, and it might be more than 100 kilobytes, but it's on average at least. And there is some increased read-write pressure on the disk because there's a presence of blobs as well. There's a new piece of the puzzle that gets added in, right? And one of the things we were really glad to have tested and are extremely surprised about was that tests on ARM machines showed that they work great. We had some help with the Ethereum on ARM folks. They're here this week. And it looks like they're able to track DevNets perfectly fine. I don't see any reason why they wouldn't be able to do public testnets as well. It shows that at least when it comes to tracking the chain, there's no added latency. And it could have been that it was worse than we had expected, purely because we're adding a lot of new libraries into 4844. So it could have been that one of them was not optimized for ARM machines, but it seems to work beautifully, which is awesome. And yeah, all of these values kind of still depend on hard to model transaction pool behavior. So we will be, so as much as we try to do DevNets and shadow forks, etc., it's almost never going to represent how mainnet looks like. Mainnet has 10,000 nodes, 10,000 plus nodes, and we're not going to be running a network with 10,000 plus nodes. So it's going to be hard to nail down exactly the metrics you need for such a network. So the only place we will be able to get them is on networks like Gurley, Holsky, etc., which is why we're looking forward to having tools that I mentioned earlier like Zatu, which would gain a lot of deep insight into how the network looks and how that's going to go. And what next? An open call to ask people to get involved in Dencun testing. So sync a node, we have DevNet 11 live now. Most of the guides that you would have used for previous testnets would still work. We should have DevNet 12 up once we're all back home, I guess. Submit blobs. I think a lot of the ecosystem hasn't necessarily started using blobs for testing yet, and it would be nice to start so that once the upgrade does go live on mainnet, you're actually seeing stuff. And break things. One thing we did notice in merge testing was that when regular people start getting involved in syncing stuff, we tend to find a lot of behaviors that we didn't find otherwise, behaviors that we couldn't have modeled otherwise. So please try syncing nodes, submitting blobs, etc., and then raising issues in case you're finding them. Most client teams have started merging their Dencun code into their master branches. So you could potentially even just use the latest release or the latest master version to join one of these devnets. So that's mostly it, and thank you. Help testing the surge, and you can find all the tools I've linked and everything under the ETH Panda Ops organization on GitHub. Thanks.
Thank you, Barry. We do have time for a few questions here.
Hey, Paritosh.
Hey.
One question I have is, what is the biggest difference? Like, what are the differences between testnet workloads and mainnet workloads? Like, what are the biggest differences you've observed? Like, one testing on Gorley or Holsky. Let's take Gorley and versus on mainnet. Like, so what are the biggest differences you observe between testing on mainnet?
So one of the really big ones, and one that took a while for us also to figure out how to test, is that 4844 and Dencun is largely a peer-to-peer focused upgrade. And that's really hard to model. We needed a lot of tools to be able to actually view it. There was a lot of things that you still can't model. So that's one of the major things. And people tend to use a lot of esoteric tools that we might not even know about. You might have staking setups that use Windows machines. We don't test on Windows. You might have Vouch running. You might have DVT setups. You might have a lot of these different things that we just don't have the bandwidth to realistically test. So we test the default, which is you have an EL, CL on one machine, has pretty perfect setup, and public testnets show us that that isn't the case, and that's what we hope to learn from them.
I have a question.
Yeah.
It seems like a lot of these tools would be perfect for an attacker to just like take off the shelf and use, or take off the shelf and modify a little bit and use to attack mainnet. How do you think about the relationship between what you build to defend the network versus like it also being an open tool to attack the network?
I think very often before we fully open source the tool, we also try to attack or think about how to attack the network, and then make sure we're at least mostly resilient to it. Yeah, as always, it's impossible to have every case covered, but we at least try to go through a bunch of things. And if it's something we notice is completely horrible, if we release it today, we also don't release it. You can try searching for AttackNet, you won't find it online. That's like a prime example. We try to hold back tools that would be too dangerous until we're quite happy that we're not able to find anything with them. And most of the ways we present our guides, etc., is more meant from a researcher / from a observer point of view, rather than from a attacker view. Yeah.
Where do you think the most under-tested portions of the stack are at the moment?
Ooh. I think a lot of it is still in the unexpected scenarios on the peer-to-peer layer. It seems like we're just starting to get good at testing the peer-to-peer layer. We haven't finished that cycle yet. Yeah, I would say that's the main one. I would actually look forward to a simpler fork that, I don't know, every time someone talks about like workers, like, okay, it's a nice box, there's a database change, you can do like 1 million shadow forks, and if it works 1 million times, it's going to mark the 1,000th and first time. And same for EOF, they're extremely confident that a lot of fuzzing takes care of a lot of issues, and we tend to treat the EVM as a nice black box that's packaged for us, and the client devs worry about it. But when it comes to 4844, we couldn't do that. It's a live network, and we do have to test it. Yeah.
All right, well, thank you. Please, another round of applause for our speaker.
Thank you.
All right. Our next speaker probably needs no introduction, but please welcome Danny Ryan, one of the EF researchers and I think one of the leaders of the merge that led us all through the merge here. So welcome.
Hello. Ooh. Yeah, my name's Danny Ryan. Thanks for having me. This is an exploration in me trying to think a bit deeper about some of the concerns I've had around, how proof of stake is evolving, different players in the ecosystem, and also how that relates to broader concerns. So this is called checks and balances, maintaining rationality across the stack. This is the first meme I've maybe ever made, so shout out to Light Client for supporting me through this. So, there's certainly like a running kind of thing around staking and also around like a lot of things in blockchain, like consolidation is optimal, it's natural, stop fighting it, let's build monopolies together. I tend to be on the left side where I'm just like, nah, dude, diversity is good, but I don't, and I have like some reasons and rationality, but like I really want to move into the right side where I'm like, I have a bit more nuanced and, whatever that guy's called, take on this. So there's a lot of questions that kind of fit into this diversity metric, and I've been trying to think, is there a common thread? Why do we want why do we want to avoid like one LSD dominating? I put a little T there because I'm not supposed to say LSD anymore, but I'll just, LSD's cool. But why avoid all ETH being staked rather than like only a subset of the total supply being staked? Why do we want multiple clients? Why do we optimize and have a proliferation of many L2s instead of just like one execution stack? Why do we have many stablecoins? Why do we want a multitude of oracles? And well, we don't necessarily have many stablecoins, but we should. Why even like getting into the real world, like a lot of regional and jurisdictional diversity across who's running nodes, who has capital, who's building applications, all that kind of stuff. And so the question is, is there a common thread? And the common thread is diversity's good. But we'll get into a bit more formal look at that. I'm still tickled by ChatGPT, the fact that or DALL-E or whatever, it just makes this stuff. This means nothing, but it's just kind of cool. So set theory, an abuse of the term. So I was talking about some of the, like how we want to disentangle sets. We want to have many different entities staking. We want to have a difference between staked capital and the rest of the capital. We want to have, there to be far more users than there are ETH holders, so that we have this kind of disentangled sets across the stack. And I was talking about this, I think, on Bankless for the first time. I talked to Mike a bit about it, and I had like a draft blog post, and I always take a really long time to publish these things, and then like I wake up one day and Mike had published a blog post digging deep into the like 5 sentences I had talked to him about. So if you want to see a much more, he's actually probably, I think I'm on the left, and then he's on the right, so check it out. Great blog post, an exploration of some of these ideas we're going to dig into. Shout out to Mike. So I'm going to use his notation. These like greater than sign generally just means like far larger. When I say A and B, I mean the size of A and the size of B, not necessarily A. And then this little squiggle sign they're approximately the same size rather than having this disproportionate relationship. So when we're thinking about sets and sets across the stacks, this is, I'm going to claim, is good. This is healthy. If A is far larger than B, then A gets to be a rational observer of B. A is not like totally entangled with B, and if B totally blows up, A is probably fine. As opposed to, if B now becomes much larger, is approximately the same size as A, now if there's an issue in B, A is no longer really a rational observer. They're totally entangled in B. And if B blows up, like A's screwed. And we can dig a bit deeper into that. So concretely, let's think about some sets. If we're looking at users all the way down to staking, the set of users is larger than the set of holders. or equal. Today it's probably similarly sized, but in a world in which Ethereum is adopted across the globe, the people that are actually like holding this as an investment asset would be much smaller, or could be much smaller than the users. Holders are greater than or equal to the size of stakers. Not all capital has to be staked. And then stakers is greater than or equal to the participation in any one staking entity or protocol. Each, I'm going to claim, is optimally if you have this greater than sign rather than approximately the same size. You can also look at this in relation to capital. It's kind of a similar mapping, but ETH is larger than stake capital. Stake capital is larger or equal to the amount of capital that's in a single protocol. So before we dig into these sets and the relationship between these sets and what can go wrong as different things happen, I just want to look at proof of stake. Often we design, like we think primarily around like the first order incentives when we're designing proof of stake and the incentives around it. So do X, you make some money. Don't do X, you lose some money. For example, you sign that attestation on the canonical chain, probably make some money. If you don't do that or sign something incorrect with respect to the canonical chain, you lose some money. And then there's this like larger incentive, do Y, double finality, and Y generally, if you're going to lose it all in proof of stake design, requires a large threshold. And we attempt, X is like very kind of default enforced automatically. Y is attempted to be forced automatically through like the inclusion of on-chain messages, but ultimately, even if there was censorship of those messages, you could enforce this socially as a fail-safe. There's also second order incentives that like are very valuable. Like the, and often this comes into like, if I break the game, I can't play the game anymore. So why would I break it? And it's valuable. It keeps people in line. Like people are thinking not just about like the money they're gonna make on this block, they're thinking about like the logistics of the company they have that's built around this thing. They're thinking about like the real world impact of like making some of these decisions. And like that's important. It's valuable to like keep a tighter bound on the first order equilibrium. But it ultimately kind of gets to like, trust me. You know, so if you're relying entirely on second order incentives, it's not your best outcome for your blockchain. You really want to have these first order incentives to be primary and these second order incentives to really be shoring it up. So let's take a look at how, we're going to look specifically at like ETH, staked capital, all ETH, staked capital, and then like staking entities in relation to that, and how these sets can exist in likely degenerate ways. So if all of staked capital is approximately the capital allocated to a single pool or entity, but it's much smaller than all of ETH, you would get something that looks like this. And those are, emojis render differently in other places. Okay, so failure in staking, as long as this like, yellow circle is much smaller than the white circle, is not going to be terribly systemic to Ethereum. Like if shit blows up, we can probably pick up the pieces. And ETH holders and potential users are a much larger set than what's going on in staking, and so they get to be a rational observer. They get to be that kind of like social fail-safe and help in the event that staking is like totally degenerated. And again, this is like a bad situation. Like let's see, we have a single entity that's dominating staking. One of the things that we really lose here is those first order incentives kind of go out the window. Like a single entity, they can censor, they can do all sorts of things that kind of like bypass the default mechanisms that like keep them in line. And so we get into like the, okay, but trust me. And so it's bad. It's very bad. It's not the outcome we want, but at least we have, you know, they're probably not gonna, if they do something terrible, we'll be able to pick up the pieces, and we get this kind of like rational observer, which is like the rest of all ETH and users keeping their eye on this thing. This other degenerate set relationship is if all the staked capital, let's see, yeah, so if all staked capital is much larger than the capital in a single entity, so we have many entities filling this yellow box, but the yellow box has grown to be, the yellow circle has grown to be the size of all ETH, and so in this relationship, you know, we're at like a 90% of all ETH is staked. This is bad in a different way. Failure in staking becomes systemic. Like, if staking blows up, like, the ecosystem's fucked. Like, it's really hard to pick up the pieces when, like, almost all of the asset is entangled in this one thing. You know, this starts kind of looking like the DAO or something like that. And social recovery becomes less of like an obvious thing where the holders are supposed to like be kind of a rational observer of the staking and potentially be like the social recovery of last resort, but all of a sudden like they're not necessarily, they're very entangled in the staking, like by default, because all ETH is staked. You could imagine maybe there's another circle where it's all users, and like the users are ultimately the social recovery, and they could be a much larger set than this and not really give a shit about the holders, and be the kind of like the social recovery of last resort, but it's not really where we live in right now. At least we get first order incentives still, because like we have a healthy staking ecosystem where like the core incentives that are built in there work, and we get the second order incentives, like people generally, you know, thinking about second order things going on here. And then we get this like really bad when you combine the two, the bad of the two. So all stake capital is approximately allocated to one entity, and all ETH is approximately staked. This failure in staking is systemic. Social recovery just like stops making much sense. First order incentives are out the window, and really we're just kind of in trust me. And trust me, and we're all like hang out, and it'll be fine. This is not the world we want to live in. I think that this is a very dangerous world. I think any of these potential mappings is certainly very degenerate. But this is definitely the worst. So I did want to take a look at the DAO. So the DAO was really exciting. It was actually when I first started paying attention to Ethereum, someone sent me like a New York Times article and was like, dude, check this out. I was like, whoa. I knew about Bitcoin, but didn't really know what you could do with programmable platforms like this, and I was very excited. There was like a fervor, there was an energy. I wasn't really part of the community, but just like started looking at this and was like, holy shit. And it was like very, like, what if? Like this is gonna change the world, which, you know, we're getting there. But like the DAO was like, this is gonna change the world, definitely. But at the same time, I was also like, this is a really bad idea. And the first mainnet transaction I ever sent was sitting on a couch with my friend and said, this is not gonna end well. And it didn't. But it got me hooked. I mean, that was like my first little hit of Ethereum. So in this, 14% of all ETH was put into the DAO. And you could potentially argue like the amount of ETH capital is much larger than the amount of ETH in the DAO. And so like probably okay, you know, maybe we're not quite at the systemic nature, but the amount of DAO ETH in relation to like all other applications was comical. Like there wasn't really anything else going on. I don't think, I'm pretty sure ENS, I'm pretty sure had not launched. Like we were hanging out playing with Mist browser. I don't know, there was maybe an NFT, I'm not sure. Oh, there was the unicorn thing. You could get unicorn tokens, and then you could put them in this other contract and then grind in the unicorn grinder and they get unicorn meat tokens. That was like the extent of what was going on in Ethereum other than this thing. So it was systemic, and there were deep concerns. Like at that point, proof of stake was like just around the corner. It was going to launch in like a year, and there were deep concerns about the relationship to proof of stake. Like if this attacker got 14% of all funds, you know, so from that perspective, it certainly like was in the systemic realm. Another thing is that we could look at the capital allocation, but we could also look at the users. Like DAO users, there was an entire almost overlap of DAO users and Ethereum users. Like pretty much if you used Ethereum, you put something in the DAO. There's probably some people that were a bit wiser than I and did not. But like most people were entangled. And like probably the miners like were all excited and put money into the DAO. And like everyone was entangled in the DAO. And we know what happened. Everyone decided, okay, well, we can't have this happen because it's systemic with respect to the total ETH that's going to break the system, and like we can't like view it as a rational observer because like my money's on the line. And so what happened? There was a hard fork. They did the DAO recovery. it was probably the right thing to do, but it was a fucking disaster. And like if either of those things had been different, it probably would have gone a different way and been a bit less of a disaster. So we had systemic amounts of capital, we had entanglement of social sets, and definitely a loss of rational observation. So let's not let staking become the next DAO. It could. We could have a huge fucking disaster, and honestly, at this point, like, I don't think the DAO like has scars, like deep scars that lasted for a long time. I think that it'd be hard to get out of a disaster like that again these days. But how? So this is kind of what we want, right? We want stake capital to be smaller than all of ETH so that we get a disentanglement of that set. We don't get like every single entity and every single piece of capital like totally entangled in the staking thing. And we want stake capital to be managed and operated by tons of different entities instead of just a singular one. And we don't get this for free. So how do we do this circle first? There's probably some in-protocol stuff that we can do. So there's potential adjustments to the rewards curve, likely making it able to go negative. So if you wanted to target, say, 10%, 20%, 30%, I think like 20% of stake is staked today, you ultimately have to disincentivize capital. You have to, like, over certain thresholds, start saying, get out of there. There's a lot of different research going on this. I don't have like a very concrete instantiation to give you here, but likely the curve needs to be adjusted. But something else, and this emoji that's a fire. I don't know. Likely the protocol needs to become aware of MEV. This is because MEV is very spiky, as you know. It's already a centralizing factor. Like if you have just a handful of validators, you're a home validator, you're going to get far below the average, likely, of total rewards with respect to MEV because of the spiky nature. You're not going to get that like random one really big thing. Whereas if you have pooled capital, you can end up getting closer to that average. And so that's bad today. It's a centralizing factor today. It's a reason that you might not stake with a small pool or stake at home. But you can at least like get some amount, as long as we don't have this like negative issuance curve. You're going to get some amount, and you can be altruistic and like not quite get as much money as if you pulled your capital. Whereas if we can have a negative issuance curve, like there's no way you get the altruistic player who's going to show up and be like, yeah, I'll take negative 3% a year. And so we really need MEV awareness such that the protocol can burn or distribute or do whatever the hell it wants with the MEV in a way that is kind of smoothed across validators. So that's like stake rate targeting, essentially like protocol changes to bound this inner circle with respect to that outer circle. How am I doing on time? You're good. All right, cool. Sweet. Now I'm blowing through this thing then. So then we have this other circle. We want it to look like this. It could obviously look much different. You could have the pink circle kind of dominating it or taking up most of it. And it's a bit less clear what to do here. And that's because the protocol doesn't really know about pools. The protocol doesn't know that my capital is different than your capital, or know that like actually our capital is pooled and one entity runs it. And so it's much more difficult. I think one thing that could be valuable here is simpler and faster reallocations. So in the event that you are pooling with somebody and having somebody else operate your capital, being able to say, you know what, entity X, I need to shift it because I don't like what you're doing, I don't like the threshold you've gotten to or whatever. Right now, it's a very arduous process, right? Like you have to exit, go through the queue, and like even when the queues are pretty empty as they are today, this is still like on the order of probably many days or a week to like get the capital out, put the capital back in, and reallocate. And that's, takes time. Time is money. So potentially simpler and faster reallocations could be a good thing. This is something that is native in proof of work. Sorry, yes, there's a couple things that are nice in proof of work. But if you're pooling your capital is mining rigs with some pool. It's usually pretty easy and quick to just point to somebody else. So I think that's something to consider. It's not you don't get it for free. There's going to be some trade-offs there because the reason that these exit queues and things exist is inherent to kind of like the nothing is stake problem with proof of stake. But I think there's definitely some good R&D to do here. Then I have some question marks because like there might be something to figure out here. This is a hard problem, and there might be some protocol changes that really help us here. But the intuition is it's hard. It's hard, and it's hard because you can't like distinguish these entities. But there's a lot of other things you can do. We have better competition. We got more product differentiation. There can be more operators, more regional and jurisdictional diversity. Risk-aware capital allocators. It's actually interesting. I got word that like someone was talking to like Wall Street people. I never talk to Wall Street people, but I always talk to people that talk to Wall Street people. And they're like very, very aware of the 1/3 threshold and like it being very important. And I was like, oh, cool. It's nice that they're actually maybe kind of are beginning to understand these protocols and risks. So, risk-aware capital allocators and self-limiting, I think are all very important things. And I think we're doing a decent job on some of these. I think like the amount of competition and product differentiation coming out and different staking protocols and products is like really exciting. But we'll see. On the self-limiting thing, like this isn't a new idea. This is something that you can go back to 2014, ghash.io. They exceeded 50% in Bitcoin mining. And it was like, the sky was falling, like it was a disaster. Like the Bitcoin community was like, we need to make a committee of miners to be watchdogs. And then ghash was like, we'll just self-limit, which kind of worked. And in proof of work mining, we've seen this across Bitcoin and across Ethereum in many ways. Like people are very conscious of these thresholds, and they don't want to exceed them because they do care about the second order incentive. And so self-limiting is kind of like a meta use. It's like pre-commitment to the second order incentive so you can maintain the first order as dominant. And I just don't think it's very unreasonable for proof of stake for players in proof of stake and the ecosystem to kind of demand these things. Because cryptoeconomic systems they have their limits. Everything has its limits. And like, if you cartelize and pool capital over certain limits, like, you break the system. Like, every system can be broken, and that's like how you break cryptoeconomic systems, is you make a cartel. So let's, demand not having cartels. Cool. Another thing is, you can take this lens and look at it across the stack. It's worth reducing systemic risk and diversifying across the stack. It's like, it's better to have many stablecoins than one. It's better to have stablecoins across many jurisdictions than one. It's better to have not just one company maintaining most of the stablecoin, which then is like piped into the decentralized stablecoin to back it as an asset. Like there are so many, like we need a proliferation of diversity here to reduce the systemic nature of stablecoins. L2s, like by default, so we used to think about execution sharding, like do data availability, layer on native execution. Honestly, like just for the sake of diversity, like for many, many reasons, I'm so excited that we ended up going in this L2 path, where like there's many different ways to try to do things. There's many different ways, one can break and not all the other ones. And so the diversity across L2s, oracles, DAOs, languages, client diversity, I think we've done like a huge win there. Tools, widgets, just down the stack. Diversity is like very good, and I think you could do a talk about many of these, and you could make your little bubbles, and you could show the bubbles, and you could talk about the risks in relation to making the bubbles too big or too small. And when not possible, follow Unix philosophy. I think when I first got into Ethereum, I thought we'd see a lot more like small, isolated, like very correct and non-upgradable widgets, where like if everyone's using that little widget, it's like not actually a systemic threat because you don't have a DAO governing it. You don't have like a huge attack surface. And it'd be really nice to see us attempt to adopt some of this Unix philosophy and layer much thinner applications on top of like well-tested and things underneath the Again, ChatGPT is pretty cool, so I asked him to make that, and it's got little circles, and yeah, anyway. Thanks for letting me rant.
We have time for about 1 or 2 questions.
Hey Danny, thanks for the talk. You had outlined the 2 problems basically that we don't want the staking to, the set of stakers and staked ETH to be much smaller than the set of all ETH. And also the one that we don't want one party to dominate the set of staked ETH. The second one is really hard to solve. In the first one, it would be possible to target, let's say, some percentage of all ETH, let's say 20%. The protocol perspective, it's how much ETH is staked. Right. Has it been any work done on that front, or basically?
Yeah, so I mean, if you go and look at some of Vitalik's papers, like I don't even think they're on like a GitHub, some really interesting PDF from like 2016, 2017. Some of it is around like target stake rates. And the assumption based off of the rewards curves work that were launched at phase 0 and still exists today, were that sort of like 10 to 20%, 10 to 30% would be staked. We were woefully ignorant of MEV, right? And MEV has the ability to, like, depending on the regime and the amount of kind of what's flowing in on top of Ethereum, the base issuance almost doesn't even matter, or could not even matter, and so you can get far exceed the 90%. I will say that Vita, the guy sitting right in front of you, and a number of people on the rig team are spending a lot of time thinking about what. Obviously, you can observe, like as you say, but once you observe, what do you do with that observation? What are the optimal, how do you like change to do it in an optimal way? So I think we will see probably over the next 6 months a lot more in terms of blog posts and some fundamental research to help us make some decisions over the next couple of years.
Yeah, thanks a lot. And to the second one, basically helping, that's the hard question, how to have the stakers as decentralized as possible. Do you think it would make sense making the protocol itself be more aware of the staking gaps so they are more easily built on top of Ethereum, or it probably doesn't matter?
Oh, so like native pooling and things like that. I think certainly an open conversation. It's a much bigger design change, and I think would not be done lightly. I mean, I think any changes at this point are not done lightly. But even then, pool that's too big using native pooling functionality, you just make 2 pools, and the protocol doesn't know. And so maybe there's some fundamental thing that I don't understand, and we can figure it out. But I think it's probably fundamental that the protocol can't know without some sort of governance, which I think we would also want to avoid. So it's a hard problem.
All right, one more question over here.
You talked about MEV awareness. Will that require in protocol PBS, and if so, is that going to be worth all the complexity and all the cons that comes with that?
I think there's some PBS people in the back. I believe so. It's like you're MEV aware, and then what do you do with it? You either smooth it or you burn it. It doesn't really matter, but MEV awareness is probably the more important side of it. I believe that there are constructions. I believe that, I don't know, do you need PBS? Last I checked, I think you do. Yeah. So PBS, right now we have like a pretty fragile but something seemingly working kind of relay thing to externalize the PBS. Likely we have to go to kind of a trustless sort of market around building and not have the relays be the last act resort. So yeah, we need it.
All right, well, thank you very much for the presentation. Please, another round of applause.
Thank you.
We'll need just a few minutes here to set up for the next panel. So if you just give us a few minutes to retool the state.
And I will change your photos.
I would like one large and one XL if you can.
Yes.
Yeah.
We have a white XL.
I would love a pink large for my wife. Yeah.
No problem. But if, how are you?
All set?
Oh, hang on, is Colfax
Cool.
there? Or I think this.
I'll sit over here, yeah,
Oh,
and
okay, so
then,
now I'm
yeah,
on the inside.
perfect.
I actually thought this was more comfortable. You think it looks more comfortable than it is?
Alrighty.
Is this plastic?
Can everybody hear me? Is this on? Can everybody hear me okay? Oh, perfect. Awesome. Well, thank you guys for joining. We are about to start the staking data panel. I'm very excited about it. My name's Colfax, and I'm a member of the staker community. And I just want to let everybody know that when I agreed to do this agenda slot, they did not tell me it was going to be between Danny Ryan and Justin Drake. So we'll see how it goes. All kidding set aside, I'm actually super excited to talk about staking data. It's a topic near and dear to my heart. And I admit the work that all three of these gentlemen do here. So I'm excited to meet you both today, or all three of you today, and dive into this. So instead of introducing you guys, I'd actually like you guys to just, share your name and what you're working on.
Hello everyone, my name is Hildebert. I work at venture capital firm Dragonfly. I am as Hildobby, and I publish some data on Dune dashboards, trying to make sense of who staked how much. That's basically the high level picture.
Yeah, hi everyone. My name is Tony. I'm with the Applied Reason, and I've been building some dashboards recently. Every dashboard that has the .pix top level domain, so it's tornado.pix, censorship.pix, mathboost.pix, mempool.pix, and mainly focused on data and research at Ethereum Foundation.
Hi, I'm Michael Sproul. I work at Sigma Prime, mostly on the Lighthouse client, but my side hustle is working on Blockprint, which is this client diversity data. Some of you might talk a few hours ago.
Thank you. So let's just start off with a quick high level. What is staking data? And
So I think it has various components to it. There's various ways to look at it. You can see it, I look at it out of who staked how much and who is the entities that owns this staking amount. But then there's also at a node operator level, which is a whole different thing. There's just a lot of things. I think we covered different areas of staking. So yeah, for me, it is the high level who staked what, but I'll let Tony talk about him.
Yeah, thanks. What I'm very interested in is actually looking at all the validators and then trying to somehow cluster them on an entity basis. So in the end, normally we see all these independent validators on the beacon chain, but in truth, we know many of these validators belong to one big cluster, and then it's very helpful if we somehow find some heuristics or somehow some ways to cluster these validators all together. Just also this links very well to Danny's talk. We want to know if there is some systemic risk to the validators, which entity is controlling how many validators, and then how these entities are behaving when it comes to censorship and all the math topics.
Yeah, I would just add to that and say that I think the beacon chain is a real goldmine of data because there's so much depth that you can on all these different metrics and different angles. Like you can look at, who's controlling the stake. You can look at how they're performing, what rewards they're earning, what clients they're using. There's just so many ways that you can sort of dice it up. There's a whole networking layer that you can dig into. And I think it's just have much more data to analyze than we have resources to analyze it. So yeah, there's probably lots more projects that could be born out of this data for sure.
Makes sense. So on the topics, actually piggybacking right off Danny Ryan's talk, on the topic of centralization of folks who are staking ETH, we heard a lot about why it's important to look at, but can you guys comment a little bit on why it's a difficult problem to solve, and why can we not always figure out exactly who's running validators, and why are there different strategies to do that?
Yeah, first of all, it's hard. First of all, the problem is, of course, centralization. We want to have a few entities that have to obey a certain jurisdiction to run a big amount of data. Just because Ethereum is credibly neutral, right? And as soon as we have validators controlling too much, one could argue that from time to time, we lose more and more of this very important credibility. And then, of course, the second big thing is censorship. So if we have many validators, for example, that have to look what OFAC tells them and have to obey the OFAC sanction list, it becomes harder and harder for normal users. I mean, currently it's only Tornado Cash and some entities that are not interacting that much with the chain, but mainly Tornado Cash that is sanctioned. And for example, it becomes harder and harder, not only for US people to use these very important privacy tools, but also for me as a European, right? It's very hard to use Tornado Cash because also the European exchange use the tools that are made in the US, and you get a risk score based on using Tornado Cash and stuff. That's a very big topic in the whole staking.
Yeah. So like the actions of a set of validators can have an impact on the entire network.
Yeah. Right.
Yeah, and therefore globally for Ethereum.
Right.
Yeah.
Would you like to add?
Yeah. So the bulk of my work recently in terms of staking has been trying to entities behind those addresses, and a difficult part is that all the decentralized actors and the protocols built on top of liquid staking and all those are very happy to be tagged. Some of the others are not, mainly centralized exchanges and stuff like this, which can be a bit trickier. So it is hard at first also to see who controls these staked ETH. And I think it is fundamental to have this picture in order to, advance discussion and all this. So yeah, I think I just wish there was more disclosures, I guess, from central exchange sides on their staked amount.
Yeah, I agree with everything that you guys have said, but I would just say that like this tension is pretty fundamental, that there's this sort of trade-off between openness and want. I'm stealing something that you said when we were talking earlier, but we sort of want openness for the big end of town, the staking pools, operators like centralized exchanges, but we want privacy for the individual validators. So something that all of us have to balance in the tools that we're building is, not doxing and outing solo stakers, but at the same time, sort of getting data that's useful.
It's definitely a tough thread, I guess. On the topic of centralization, I want to talk a little bit about client diversity, something I'm really passionate about. Michael, can you talk a little bit about, I guess, just high-level client diversity, why it's important, and then secondly, like, why is it so complex to figure out who's running clients?
Yeah, so high level, the reason it's important is that we just, we don't assume that any of the software that we've built is perfect. So if there's a bug in any client, we don't want that to absolutely destroy Ethereum, because since we've moved to proof of stake, it's actually a little more risky to have a concentration of stake on a single client, because if you finalize an invalid chain, it's basically game over for everyone that voted for that invalid chain. They lose all their stake pretty much, unless we bail them out, which we shouldn't do. So yeah, that's kind of a difficult thing. And then in terms of the client diversity data, there's this, again, it's kind of a balance between, we could just ask what clients are you using? But then these systems are always able to be gamed by, if you attach any incentive to say, if you run the minority client, you get an extra $10 a week, then suddenly people have an incentive to go and hack whatever that measurement is, and then you're basically fighting a constant arms race to try and get ahead of people. Or you have to put something basically like a DRM in the binary that says there's a signing key in here, and then you're fighting an arms race on DRM, and that's it's kind of anti-privacy as well, because you're outing your client usage without if the users, if it's opt-out, so I think that's not a good idea. So yeah, it's kind of, we're just doing the best, I think, with and trying to adhere to the decentralized ethos of the project and the sort of pro-privacy thing.
Yeah, and maybe just a little bit to add, because I was also using Michael's tool, so it's open source, Blockprint. It's very nice, and the cool thing about it is you can pass in a block and it will classify that block. So it doesn't need you to set up a node and connect to as many peers as possible to then find out what client they are using. But you can just take a block and then look at certain features in that block, for example, how attestation, what graffiti the block uses, and then come up with a quite reliable estimate which clients used. Because on the execution layer, it's much harder. So the best approach there is probably to set up a node, max out the peers, and then connect to as many other nodes as possible. Ask them which client they are using, and then disconnect again. And yeah, to kind of expand on that as much as possible to get a better overview of the whole network. So it's much easier to check per block basis, but this is not possible on the execution layer because you can't look only at the okay, this was for sure a GEF, this is a GEF block, or this is an Aragon block.
And so talking a little bit about the difference between like the execution layer data and the consensus layer data, a lot of the staking data that we're talking about is happening on the consensus layer. Can you talk a little bit about the differences between analyzing consensus layer data versus execution layer data?
Yeah, sure. I mean, I could talk about how we leverage, for example, execution layer data in order to improve our consensus layer data by, for example, looking at the deposit address. For example, to use one deposit address if they stake their ETH, and then it's quite straightforward to just, if it comes from one deposit address, then it's one entity that deployed these validators. There are other heuristics. I think you found them out, right? With looking, it's more sophisticated heuristics that you apply to the execution layer data to then find out, okay, if there is an address that is an active staker while it has sent a few ETH to some Coinbase address, then we know, okay, this is a Coinbase staker. So for some entities, it's very easy. You just look at the deposit address and say, okay, we cluster all these deposit addresses, we cluster all the public keys that came from a certain deposit address. For some, it's much harder because I'm not sure if they try to avoid that they're being clustered, but they force us to come up with some heuristics to then identify them. Maybe you could expand on that.
Yeah, so originally on depositor address, but there's many different ways, and the goal is to have simplistic that has all the taggings, but with a minimal amount of lines. So if one entity uses always the same address to initiate the transaction, or the same address where the ETH come from, or the same withdrawal keys, you can all leverage all these different things and with that heuristic. And yeah, I'm trying to make sense of, it's not always the case. Some can only provide, the validator index or something like this, which is harder to work with, I guess. But I try to make sense of this, and I have a table that is for anyone to use on Dune. Anyone can download it. Anyone can more entities that they have detected at themselves. You're also free to reach out, and if you want your own entity, or you have a V2 or a V3 that is released with a new protocol underlying new underlying smart contract, tell me, and I'll make sure to add you. But I only touch on the execution layer data because Dune currently doesn't have consensus layer data. I am pushing them to add it. Hopefully that happens soon. And I'm excited to, once they have it, to tie both together. There are very different types of data, but I think the full picture needs both. So yeah, I can let Michael talk a bit on this.
Yeah, this just brings to mind for me, one of the issues we have on the consensus layer is that because the software is a little bit newer, we don't have archive nodes that are maybe as efficient, space efficient as the execution layer archive nodes. So running a CL archive node has been something that's been quite difficult. You need I saw someone syncing one today, and they got to 6 terabytes with Lighthouse before they'd even thinking. So that's pretty horrendous. We've got a long-term project to fix that. We've got an archive node now that fits in gigabytes for Lighthouse. That's an experimental one. But yeah, we're hoping to release that after Deneb. But our hope is that this makes a lot of beacon chain analytics just a lot more accessible, because anyone with 150 gigs of space can get an archive node and then have access to a lot more historic data and just do whatever analysis they need to do. Yeah.
So far we've been talking a lot about collecting data and analyzing it, but there's really a whole other component about visualizing this data. And so the awesome designs that you showed off in Blockprint earlier in your talk today, and then of course the .pix websites, and then Dune does a great job of helping visualize too. I think we're actually doing a pretty good job of visualizing the underlying data, but I'm curious what you guys think and sort of where the big gaps are in terms of visualizing and really translating this information to something that people can understand.
yeah, like I think it's a unique skill to be able to come up with, will intuitively understand when they see. Like, I know that for me, I've had to work quite hard to iterate on this to make them accessible and understandable. And the Blockprint UI, I think, is hopefully understandable because of the work and the feedback that colleagues who were like, what is going on here? Like, what are you doing? And me then going, okay, I have to tweak how this works. But yeah.
Yeah, I think on Ethereum we are already doing quite a good job in making also sure that all this data is then open source. More or less I did the same research that I do now on Ethereum, on Bitcoin, and it's much harder, I can tell you, much harder to get the labels to add. There are some open source databases, they are very small, but on Bitcoin, for example, you can really see that these big players, they have the labels, they have all tagged addresses, and they are not happy to share that with anyone. So not even if you're a researcher trying to do trying to write a paper or something, they would never share the data with you. And for Ethereum, we already have a really big fight. We identify more and more solo stakers every day, and this is just nice to see that that it's not only the big players that then have that data, can use it, can sell it, but it's more or less open source and everyone can use it.
So in terms of visualization, I also iterated a bunch on dashboard over the years, over the month. I started it a year and a half ago, and at first no one really cared, I guess, about this data. And then ETHtaker came by actually and did a crowdfunding round where I was able to get some money out of it when I was independent, and that also pushed me to keep improving it and keep it up to date. And you know, I tried to present it in a way that you data, and slowly as you scroll through, you go deeper and deeper, because that tends to be how people react to what they want to see is the high level, and then slowly dig in. And yeah, as an analyst, you have kind of a two-part job, which is one of them is making sense of the data, but then also the second part is making for people to understand and presenting it in a really efficient manner and an easy way to understand. If you see the chart, you should directly looking at. It shouldn't be a bunch of labels, complex to read and stuff, so that it is. Otherwise, if I see a dashboard and it's really, really complex, I just click away. I don't necessarily have the time to process what is there. And a lot of data is lost sync, just people who are amazing, really, really smart, but don't necessarily put in the work on the visualization side. So yeah, I encourage all analysts to actually work on the visualization. I think it goes a much longer way than the belief to get the data out there seen by the public. So yeah.
I'm glad people are now paying closer attention to the actual data that's going on related to staking. And so much to the point that I see ongoing active public discussions around client diversity, stake distribution, censorship, how to handle it. What do you see as the up and coming sort of like new types of data analysis that we're going to start doing on staking? Or what are new things that we should start focusing on next?
We focused more and more on solo stakers, so identifying solo stakers to also get a picture of how many solo stakers we actually have. We were quick in finding out which validators belong to Coinbase, Binance, etc. But for the solo stakers, it's much harder to know, is that a solo staker or is it maybe another Binance validator that just pretends to be a solo staker now? This is not that easy, of course, because there's no heuristic that says, okay, a solo staker always looks like this, right? But of course, for example, many people have used their ENS addresses to deposit ETH. Then you can look at has this ENS address been used with some big entity or not? And most of the times you can then really quickly find out, okay, we have a quite high probability of having identified a solo staker, and through that so I would say the identifying definitely something that is coming more and more to this staking data.
Cool. I understand sort of the balance between privacy and publicness for solo stakers in particular. If there is a solo staker that's listening to this and doesn't mind publicly identifying themselves as a solo staker, is there a way they can do that to help you guys out?
You mean they want to be?
They do, yeah, the solo staker on this address. Ideally, there's some way we can prevent people from falsely claiming that, but yeah, is there any way they can help out?
I mean, especially when it comes to solo stakers, right? I guess privacy is very important. So even if solo stakers provide their, yeah, it's really hard, right? Because at some point it should be anonymous. And I mean, solo stakers could reach out to me and tell me, please don't say it to someone else, to your data set, but anonymously I would do so. But yeah, I totally get why a lot of solo stakers don't want to be identified. Right? It also adds risks when you think of DOS attacks or it's just a balance between, as Michael already said, tagging and publishing all the big entities while still respecting.
Makes sense. And so in terms of other new things, I recently heard about the new rewards API. Can you tell us a little bit about it, Michael?
Yeah, so this is sort of trying to fill in some gaps that we felt were there in the data about rewards. There's historically been, block explorers that will show you, oh, you were tested in this epoch and you got a reward of this, right? And they sort of had to reverse engineer basically the rewards algorithm that the consensus layer uses. So to improve on that situation, some awesome fellows from the EPF, it was actually the last round, worked with us on standardizing a new API for rewards. And now there's sort of experimental support in Lighthouse and in Teku and a couple of other clients where you can say, okay, at this epoch, what rewards did this validator get, and sort of give me a breakdown by how they attested, like whether they attested correctly and matched the head, whether they matched the target, the source, for blocks, which I think is really interesting, showing the profit per block, which is something that I think clients compete on and should compete on, and is like a kind of fun, for us as client devs, it's like a fun optimization problem to compete on that. And then with Deneb, we've also got this cool thing. We're going to surface some of this rewards data in the production pipeline. So if you're running a validator client like Vouch, which uses multiple beacon nodes blocks, it will now, at the moment it uses a heuristic to choose which block is the best, but it will now get a little HTTP header that says, okay, the reward for this block is such and such ETH, 0.3 or whatever. And it can profit max and just choose. I think this is actually going to have a benefit for client diversity as well, because it turns out that at the moment Vouch is preferring Prism, but from the Blockprint data that I have, it actually looks like Nimbus and Lighthouse are probably the more profitable blocks. So hopefully we'll see setups will have Nimbus and Prism side by side, or Nimbus, Lighthouse, and Prism. It's going to choose more Nimbus and Lighthouse blocks, which is going to sort of give us a better indication, these multi-validator setups out there. Yeah.
And so I enjoyed talking to you earlier a little bit, Tony, about how you got involved in staking data and making it more visual. Dune is an amazing tool for people to just experiment and play around. If somebody wanted to get involved and try and help out, or just learn more about how to analyze staking data, can you make any recommendations for how people can get started?
Yeah, so currently I'm hosting an open source dataset on mathboost.pix/data. So it contains blocks since the merge with the identified validator who put a relay that relayed the block, the builder who built it, and it's open source, so everyone can download it. It's in Parquet format. Yeah, I've made quite good experience with that, so people are really using it, and it's also because any visualization that you can see on mathboost.pix can be generated from that data set. So it's quite rich in information. But yeah, if you know how to deal with that, then it's quite simple to actually rebuild the whole website.
Very cool.
Yeah, so I think, so there's two parts to making data. There's the data engineering and then the visualization. The data engineering with open data sets like his, or I also have some on Dune, I think those easy to actually leverage those and visualize what you want to see that may not be currently available. So I encourage anyone to play around with those data sets. If you have trouble downloading some of Dune, you can always reach out. As long as it's not to put it behind a paywall, I'm happy to provide it. So yeah, I encourage all researchers to, this we are not looking into. There's so much space for many analysts to collaborate on. If you're a protocol or are staking yourself, feel free to signal which, whether it's a deposit address or something you're using so you can do. Yeah, I think just there's many ways to help, so there's space for every contribution.
Well, we just have a few minutes left, so I want to close with one question, and I'd love for each of you to answer, audience. So given the view that you have on the Ethereum ecosystem from analyzing all the staking data you've seen, if you have a magic wand and either like change or fix one thing about Ethereum, what would you change?
Yeah, that's a good question. I would say it's not a change that I would propose to Ethereum, but it's more a change that I would propose to all pools, and especially the centralized ones, to just be open with their validators, to not hide them behind some like deposit logic and stuff, because it's very hard for us to find out who, for example, to call them, it's Coinbase mainly, right, that have a very complex logic to somehow deposit into the beacon chain, and the other one is
It's Coinbase that takes fish contract.
Right. And so it would be much easier if everyone would just use one deposit address for depositing. And if not, if they would just have a simple GitHub Pages page where they would just put up their deposit address. It's simple, right? And for a big company, this takes them a few hours to set up. And it would help us a lot to really reliably tag the validators. Because sometimes people reach out, actually we have 2% market share, not only 1%. And then you have to ask them, yeah, but what's your deposit addresses? And then they're happy to provide them, right? But why not directly, actively providing them somewhere?
Yeah, I think Coinbase is a good one. Got it by making validators from, like creating an address for every single validator. So that was already a pain to track. There's 160,000 addresses they use to deposit ETH. They lost like 1,000 ETH just in gas to do this. And it is basically to hide themselves originally on chain. I think now that they forked Stakefish contract and now are depositing from it. But I just wish there was more transparency generally, some way to, at least for big actors like this, to know publicly that they are behind those addresses would be great. Because even now I'm relying on like their quarterly reports to check if the numbers match mine. I'm currently missing 3% for them, so looking for those. But yeah, it's kind of a cat and mouse game where it's the never-ending one where actors don't necessarily, first, they don't necessarily have an incentive to disclose all this, and I understand that, of course. I think for the sake of Ethereum to have those disclosed, and yeah, maybe there's a middle ground in there.
I don't really have anything to add, so yeah, I think let's do questions.
Cool. Well, thank you all for joining. I enjoyed chatting with you, and I learned a lot, and I hope you guys had a good time.
Hello, test one. I apologize for how many questions are built into this question, but whose responsibility is it to fund the capture and analysis of staking data? Because it's fundamentally important in measuring decentralization, but there's currently no incentive to building in ways to measure. And in fact, incentives are the other way around. There's incentive to hide your staking data and maybe like pretend to be a solo validator. So whose responsibility is it to fund that data, and whose responsibility is it to make sure data?
Yeah, I guess there are not that many incentives getting invited to a panel, right? So I think it's also in the responsibility of especially the big ones, right? They care about the protocol, so they might want to. It should be an incentive enough for them to be very open and transparent, and also answer Telegram messages when you're asked like how is your logic, how does the look like. So I think it's also the responsibility of the stakers themselves. I don't think that, yeah, I'm not sure about how to fund that. Of course there are many grants that are happy to support open data and dashboards, but except from that, yeah, I don't really have an answer how to fund that in a very sustainable way, except from somehow spinning a business out of it, like Dune did very well, and yeah.
And rated, as Michael said. Yeah, I think we're probably curious nerds at heart who just want to get that data ourselves. So the incentive is probably curiosity. I don't know if that's the same for you guys, but it is definitely for me. And I couldn't find this data when I wanted to look into it, so I got frustrated with myself. And my incentive is that, yeah, just intellectual curiosity. There is still 18% or so that are somewhat undisclosed of who is behind this ETH, and I keep trying to tag those, but it has diminishing returns in terms of time spent and what you discover over time. But yeah, it's really hard to fund anything that is kind of sector level. When a team is directly involved, it is directly the data. They're usually happy to fund it. But when it is a whole sector and they're comparing different protocols, teams are actually probably more interested in this, but no one's willing to fund it as a whole. Like he said, it's probably DAOs and of money that maybe can fund it. But yeah, I think luckily we have curious nerds, I guess.
Ken, do we have time for one more question? Take it away, Henny.
Hello. Once we have more accessible and efficient CL archives, what type of insights and analytics do you see becoming available?
So really cool, and we've started working on this in Lighthouse, is that we've got a validator UI, and that's basically like a local block explorer pretty much. And there's other people working on local block explorers like Autoscan. So I think just it really improves the sort of accessibility of that data, and you can have your own data and keep track of your. In terms of new things to build, I can't think of any really cool ones off the top of my head, but I'm sure people will come up with amazing stuff. Basically, block explorers on steroids would be awesome, in my opinion. And then, yeah, whatever.
Thank you. Well, everybody, please give another warm round of applause for our panelists, and thanks for coming in. Nice job, guys. Yes.
Take the headset from me.
Perfect.
Justin Drake, Beacon, Shane. All right, is it ready?
All right. Thank you all. I'll get us going really quick here. Another person that needs no introduction is Justin Drake, a researcher with the Ethereum Foundation, and he's got a very tight, so we'll go ahead and pass it right over to him.
Okay, perfect. Thank you. So today I'd like to do a bit of a retrospective on the design, trying to highlight some of the mistakes that we made and basically explain how we messed up, but maybe we can improve next. And yeah, I think that, you know, we have made significant mistakes. So if we hadn't made these mistakes, if, you know, really, really awesome. But we have made some mistakes, and let's have a look what these are. The mistakes in kind of two sections. One, like painful today, obvious mistakes, and then, you know, things that might come bite us in the future. I think the biggest mistake that we've made that's biting us today is the max effective balance. So we capped the amount of ETH per validator to 32 ETH. And the reason why we did that is for sharding. We used to have a sharding design with these sharding committees, and it was kind of important that the sampling was done very, very smoothly. You didn't want any lumpiness with very big validators kind of overflowing like one of the committees. But with dank sharding, we have this awesome new design which doesn't require committees. So we don't need to cap the validators. So that's pure technical debt in my eyes. And that comes with consequences. It's like unnecessary friction for the validators. We have way too many validators. We have, roughly speaking, a factor of 100 blow up like operators to validators. So roughly 1 million validators and roughly 10,000 operators. Big overhead there. And we also have suboptimal compounding. If you have 32 ETH, right now, in order to do the compounding, you need to wait until you have 64 ETH. And so when you have 33, 34, 35 ETH, you're not making use of that additional ETH as a solo validator, at least. And the obvious thing here is just to remove the max balance. And the way that we plan on doing that is in 2 steps. One is to increase the maximum effective balance from 32 ETH to 2048. But also eventually just completely remove it, because we won't need it in the long term. Now, in terms of like this one mistake, that has like rippling consequences. So for example, the fact that we have too many validators puts a lot of load on the clients, but it also means that future upgrades are harder. So for example, Enshrine PBS, which requires 2 rounds of attestations, harder. Single slot finality, which also requires an extra round of attestations, much harder to do. It means, you know, we have longer slot times. It means that we have, you know, maybe unnecessarily high minimum deposit. So we could be having 16 ETH validators or 8 ETH validators, but because of this one design mistake, we have 32 ETH validators right now. Okay, and I guess the compounding is, you know, obviously a source of unfairness. It's a source of centralization. It's not a good look, and it also has impact on the withdrawal queue, because right now what happens is that as soon as you have a little bit more than 32 ETH, then if you've observed that, but basically you have these partial withdrawals that will sweep the extra balance from all the validators, and that takes a whole week more or less to sweep through the whole validator set. And that you know, means that if you want to do a full withdrawal as opposed to a partial withdrawal, you have to pay the cost of waiting roughly a whole week, which is, you know, totally unnecessary. Okay, next big mistake, which is actually very much related to the first mistake, which is the committee index. So we used to have these shard committees, and there was an associated committee index. And what's happening is that at every slot, we have different committees that are signing different messages. And in the previous design, basically, each shard would have its own state root, and so it was kind of normal to kind of index them. Because these would be different messages signed. But turns out that now we can have all the validators sign the exact same attestation, and BLS aggregation works basically when it's the same message that's being signed. That's the key trick. And so we have, like, roughly speaking, 64x overhead on verifying signatures, which is pretty crazy. And it also affects normal clients, but it also affects light clients. Like if you want to snarkify the beacon chain, now you need to have a circuit which can verify, you know, all the pairings to do the signatures. So that's a very kind of silly mistake in hindsight that is causing a lot of pain. And the obvious you know, fix is just to remove the committee index. This one is also kind of big facepalm. Basically, we have this feature which is completely unnecessary, whereby we're gating withdrawals with a BLS signature, but like withdrawals where, and like eventually it's back to ETH1, and so we're causing all this unnecessary friction with the initial validators that had to set up cold storage without a hardware wallet because there was no support for BLS signatures, and then all the stress. I don't know if you've gone through the stress of like going from 0x00 to 0x01. It's like not nice. And then there's like this useless feature that's there that's like not helping. So we messed up here as well. Next up, proposer rewards. So this is kind of a fun one. It's one that I realized only recently. But basically, right now there's this proposer lottery. Roughly speaking, once every 4 months, as a validator, you win the proposer lottery. You get to propose a block, and you get some issuance that corresponds to winning the lottery. And really, what we should have done is we should have done a proposer penalty in case you're offline. So you still want an incentive to be online, but instead of having a reward which creates this high variance, you want to have a penalty in case you're not offline. And most of the time, like 99% of the time, folks are online, and so it would be like a completely flat, APR and reward curve. And this variance is one of the reasons why we have this pooling, and it also makes future upgrades harder. So, for example, we want to do stake capping. Where we have this issuance curve which goes towards negative infinity once you reach the stake cap, and in order to do that safely, you need the variance to be very, very low. So this is a fix that we could do at some point in the future. Okay, issuance curve. Kind of talking about issuance. I think we did a pretty good job with the issuance curve. But one thing in hindsight is that I think we're just overpaying for security. We have a huge amount of economic security right now, almost 60 billion, and I think we could have reduced by a factor of 2 the issuance. And another thing that we kind of messed up a little bit is that there's no stake capping, and that would have been extremely easy to do if we had thought about it earlier on. Basically, is this idea that if you want to have a maximum amount of stake, let's say 30 million ETH, then as soon as you start getting close to this, so the amount of stake gets close, the issuance goes negative. And then there's also no stake lower bound. So if there's for some reason there's a very small amount of ETH staked, let's say only 1 million ETH, there's no real incentive to really push people to stake and increase the economic security. And that we can do something similar, but where basically the issuance curve starts growing very, very fast as soon as you're below kind of a safe threshold. And instead of a square root, basically my suggestion is to use a cotangent, which basically starts at infinity and then goes to 0 and then negative infinity. Okay. Fork choice bugs. So we've had mainnet issues, and not great, but also it's just caused so much friction for the developers and various researchers, including academics, because we've had these academics look at our fork choice rule. They find all these little edge cases, and then we try and fix it. And the process of fixing the fork choice rule introduces more attack vectors, and then there's this cat and mouse where we keep fixing and breaking, and it's just very resource intensive, and it's also not a great look. So really, what we're working towards, and I think we're getting close, is basically a provably secure fork choice rule, which is bulletproof and won't have to be fixed on a continuous basis. Ejection balance. So right now we have this process where if your balance reaches 16 ETH, you get automatically ejected from the beacon chain. And unfortunately, there's about 0.2% of validators that are just permanently offline. And these zombie validators that are just leaking ETH for no real reason, and they're also kind of affecting, to a small extent, the liveness of the chain. And so it's just unnecessarily harsh to those validators, and it's all very inflexible. And so really what we want to be doing is having faster ejections and also more dynamic ejections. So if you have 99% of the validators that are online, then it's actually safe to eject people that go offline. But if you have a mass problem where 80% of validators go offline, you don't want to eject. You want to give them a chance to come back in. So you want to have this dynamic logic to take care of that. The effective balance. So right now we basically have 1 ETH increments on the effective balance. And it was done as an optimization to improve the Merkleization, but I think it's probably unnecessary complexity. And it also adds problems to the compounding, right? Because if you have 31.9 ETH, now you have 0.9 ETH, which is not working for you and not actively staking. And this again is a centralization vector, because like the really big stakers, for them 1 ETH relative to all their stake is a tiny portion. And so the obvious solution here is just to reduce the increment, maybe bring it down to 1 gwei so that we have a single balance on the beacon chain, not 2 separate balances. Slot boundaries. So this is more of an aesthetic thing, but for some reason our 12-second slots don't start exactly at the minute. They start kind of 1 second before the minute, which is kind of a bit arbitrary, a bit strange, maybe a little unpolished. Okay, and I think that ideally we would have aligned slot boundaries, but it's kind of, now that while we have it, it's changing is actually quite difficult. Okay, painful stuff that might be painful in the future. So one of them is the talking about slot durations, is the 12-second slot duration. So it turns out that just like the fact that we have too many validators, the fact that we have a relatively short slot time makes it difficult to do certain upgrades like single slot finality and enshrined PBS. And the reason is that these upgrades add new rounds of attestations within a single slot. So basically a single user level slot now has multiple system subslots. And so if we stick with 12 seconds, now we have 6-second subslots to do these attestations and aggregations with potentially hundreds of thousands of validators, and it becomes very difficult. And so the obvious fix here is to increase the slot duration. But I think just changing the value is going to be just difficult. It's going to be a coordination nightmare. And I think some users or some dApp developers will push back on larger slot durations. So that's going to be an interesting development. Another thing which is a little bit underwhelming is the sync committees. So that there isn't much adoption today. We have all this infrastructure for light clients with the sync committees, but not much adoption. And also the thing that's kind of annoying is that we don't need sync committees in the long term. It's just a piece of temporary infrastructure until we have like a fully snarked beacon chain, which is your light client. And so it's kind of over time going to be a piece of technical debt, which maybe we should consider removing, or at least removing some of the incentives attached to it, so that we reduce the cost of sync committees. Uncapped penalties. I mean, this is a bit more of a bleeding edge and like maybe more controversial thing, but basically today, if you want to build a rocket pool style liquid staking token, it's not fully trustless. And there's a very easy fix at the beacon chain level, which is just to cap the amount of penalties. So for every 32 ETH validator, for example, we could cap the penalties to just 4 ETH. So if you get slashed, maximum you lose is 4 ETH. If you go offline and you start leaking, maximum you lose is 4 ETH. And then the 28 ETH is now like guaranteed kind of unslashable. And so now you can build rocket pool where like the R ETH is like as good as if it was built natively, almost like an enshrined liquid staking token. So yeah, that's a possibility. It's a very easy fix technically, but I guess we need to look into the consequences. And then here, okay, this is a bit of an interesting one. Basically, if we're going to increase, and I think we will increase the maximum effective balance or even remove the maximum effective balance, now basically people will be making deposits that are much larger than 32 ETH. And in order to retain the fairness of making deposits, we need the amount of gas used to be proportional to the deposit. So if you deposit, for example, 64 ETH, that should cost twice as much as depositing 32 ETH. If you deposit 1 million ETH, that should be correspondingly larger. And right now, the way that the gas scheduling works for the deposit contract, first of all, it kind of it varies depending on like if you get lucky or unlucky with the Merkle tree, but also is not fair, is not scaled to be to stake basically. And here the obvious fix, which if we had done it earlier back then, it would have been very easy. But now the deposit contract is like a piece of infrastructure that's very, very hard to remove. So we're kind of stuck with it. And then I think this is my final slide, which is BLS signatures. So I think BLS signatures have been really successful, but the one thing that will come bite us in maybe 10, 15 years is that they're not quantum secure. And so we're going to have to kind of rip everything out and also remove other pieces of cryptography which are not quantum secure. And it's possible that we have to rip out so much cryptography and redo so much of the internals that we kind of have like Beacon Chain 2.0 or Ethereum 3.0. And I guess at that point, there will be an opportunity to just clean up all the technical debt and have a design which is essentially close to perfect. And that's it. Thank you.
Let me ask Justin first, because I know you're on a tight time frame. Do you have time for questions or no?
I can take 1 or 2 questions, yes.
2 questions. Who would like it?
2 questions.
Anyone?
Do we have a quantum secure algorithm that supports aggregation, signature aggregation?
Yes. So the cryptography team within the Ethereum Foundation has been looking into that quite a bit. Basically, at a minimum, we have Fry-based, basically similar to the Stark technology, signatures. And you can do recursion of snarks in order to do the aggregation. There's something even more efficient, which is basically lattice-based. So lattice-based. So lattices is this very promising piece of post-quantum cryptography, which still has like these powerful properties with the homomorphisms. And so we can get maybe similar things to BLS signatures, where you just add the signatures together, and then they just magically aggregate.
All right, and just one last question, maybe I'll throw you here, is of the ones that you covered, there were quite a lot of maybe things in hindsight. What is your level of confidence? How many of those could be fixed in the future, and how many of those we'll just have to live with?
Yeah, so I think the good news is that most of them can be fixed. And if we're thinking about Ethereum 3.0, then everything can be fixed. But the good news is that the worst one, 32 ETH validators, that's something that we can fix. There's an EIP for it. It's called Increasing Max Effective Balance. I think it's a no-brainer. I think we should do that as soon as possible. And so I'm hoping it will happen, maybe not in the next hard fork, but the one after that.
Yeah. All right, well, thank you again for your time today. Everyone?
Thank you.
Our next talk is scheduled for 3:45, so you have a 15-minute break. 3:45, please.
That's perfect. Let me, okay.
Okay, welcome back, everyone. Hopefully you had a chance to enjoy that break. I'm very pleased to introduce our next speaker. This is Alex Stokes. Alex is a researcher with the Ethereum Foundation, and he's going to be giving a presentation entitled...
Hey everyone, let's see. Okay, sounds like you can hear me. Yeah, I think the scheduled talk title was something like very extreme, like staking economics, MEV, and like the future of Ethereum. I'm not exactly sure where that came from, but basically I thought it was like a good sort of art, and I've distilled it down into what I'm going to call the state of our union. Basically just looking at like what we've done, where we're going, maybe how we're going to get there. Let's dig in. So, yeah, I mean, this talk might be a little more like trying to understand, like, yeah, like what are we all doing here? Like, what really is Ethereum anyway? All together, we like maybe we stake, maybe we like, I don't know, do all the crazy stuff that the protocol allows. But yeah, let's maybe try to define that a little bit more concretely. One thing we can say is that it's a successful crypto economic protocol. You know, these are the types of things we mean when we say blockchain. And I have some like graphs here. So yeah, a lot of numbers. I mean, the main point to take away from this is I was just trying to call out that like there's this like staking layer that many of you are aware of. And yeah, like it seems like it's been a resounding success. You know, we've had the merge recently, and this is now a chart here of staking supply. And basically, you know, it's like up only. People seem to like staking. And yeah, there's some like absolute numbers here. So you see there's like over 28 million ETH staked. That's like 23% of all Ether, which is like actually quite a lot. And then like drilling in a bit into like the protocol details itself, you see like these numbers at the bottom where, yeah, we don't have to get into them, but essentially it's just saying that like the activity on the beacon chain in terms of the protocol execution is like very healthy. So like almost 100% sort of participation by each validator. The messages they need to go on chain get in like pretty much immediately. That's good. This says 99% correctness, basically saying like when I run my version of the protocol, like do I agree with everyone? And again, numbers like incredibly high. There's this effectiveness. Anyway, point being, you see it's a bunch of very high numbers. That's all very good. So that was like kind of, you know, me claiming there's a successful consensus layer. There's also the successful execution layer. This is like the top, let's say 50 gas guzzlers from Etherscan I just pulled yesterday, and you can see there's like all these applications. Uniswap is at the top, different like Telegram trading bots, Tether the stablecoin. What else is on here? Arbitrum, so like layer 2s. That's pretty cool because people are actually like not just using like Ethereum, the execution layer, but also using it for like their different blockchains. Yeah, people seem to really like Ethereum. And, you know, there's a bunch of stuff here. ZK Sync, Starknet, Circle, USDC, more stable coins, all kinds of stuff. NFTs at the bottom there. Point being is, in this next column I called out, you see people are paying like millions of dollars like to use the chain, right? So it's not just like, oh, we like this because like we can like run some code and like just watch it happen. It's more like, you know, you would imagine these people are getting at least that much value out of what they're doing if they're paying for it. So you have all these applications on top of this consensus layer that we have. There's all of DeFi, stable coins I'll call out because that's like a pretty important category in its own right. NFTs, people really like these like digital collectible things. Ether just itself as like a product or application. There's this whole, you know, arc of establishing Ether as money. Layer 2s that I called out, all this fun stuff. So we have a very successful consensus layer, very successful execution layer. And then, you know, I think it's also important to note that like we are trying, well, at least some of us are trying to establish this core asset Ether as a money, right? As like a monetary product. And really what I'm trying to make, the point I'm trying to make here with this slide is that there's a successful economy like on top of all of this stuff as well. I'm not endorsing this NFT collection. This was just the top one on OpenSea, but I just grabbed it because it was handy. Really, the takeaway is simply that they price things in ETH. This is like showing that like people do actually use Ether, in this case as like a unit of account, one of these like primary properties of money. That's pretty cool. Right now, the like Ether market cap, to the extent that's a useful metric, you know, 245 million. That's like quite a lot considering this was like nothing just a few years ago. We've like kind of memed this all into existence. That's pretty cool. And this is interesting if you like, so I went to this list I found. The website was like Worldometers. Either way, you look at like GDP by country around the world, and if you put Ethereum as like sort of a nation state in this list, it sits somewhere between like Peru and New Zealand, essentially like top 50. That's like a big deal, I think. Again, considering it was like nothing just years ago. And also too, right, like, so there's like this protocol bit, right? There's like the consensus layer, execution layer, the apps that use it, but on top of that, there's like this social layer, right? So you have this like incredible community that's like why we're all here. I honestly ran out of steam just like finding all of these images. Like there was like so many more events that like people are putting on all over the world, and it's like so exciting to see. So that's pretty cool. What is Ethereum? Here's like a very dense answer. Blockchain protocol, hosting a digital economy, coordinating a passionate community. Pretty cool stuff. That being said, I want to like zoom out a bit and like start to ask like, what will it mean in 50 years? So like not just like, oh cool, like we have this blockchain and like we like swap some tokens and maybe some of us are rich now, that's exciting, whatever, but like, you know, in like 50 years, 100 years, 1,000 years, like no one will care about that, right? It's really, we can ask like, what are we doing here that will like mean something like in like a time scale that's important? And that's when you can start to ask these like very big abstract questions around like, what are we doing? What is Ethereum like as a project? And you can like quickly get into like all this theory around like building institutions and like things like that. So one way to see this is that like, you know, there's like collections of humans through time, and we like try to make up these different institutions to basically help us organize ourselves and like figure out how to make sense of like the chaos of reality. There's like things you've heard of here in the middle, like your tribe, a church, nation state, these different things that we've built. You know, generally they like collect bigger groups of people, so then you have new challenges as they get bigger, but ultimately we have these technologies to help us like coordinate, again, yeah, all these like bundles of people doing all different random things. And yeah, I'm again not endorsing necessarily these politics, but there is this like different, or there's definitely this like core in crypto ethos of this like cypherpunk idealism. You could imagine there's almost this like digital state, and Ethereum could be seen as a realization of these sets of ideas. So again, zooming way out, one way to think of this is like Ethereum is like essentially this like state building exercise. We are coordinating on the internet to make all this happen, hopefully in a way that it like makes us all better off. Also, this is just a random location. I just picked it. I wanted to pick an empty spot on the map. But who knows, you know, some of you are into these like network state ideas, and like maybe one day there's like a physical realization of the Ethereum network state, and we like build some seasteading complex wherever these lines cross on the Google map. So my point here is that, yeah, like what is Ethereum really trying to do in terms of like being a really big impactful project that like people will write about in the history books, you know, 50, 100 years from now. One thing we could say is that like there's just like so much going on in the world, especially as we like have this like information revolution. You know, like we weren't meant to like sit and like deal with social media. Like it's here just to like take our attention and like distract us 6 ways to Sunday, and like it's kind of a huge mess, as you probably are all very familiar. And because of that, my claim is that like institutions that like have these like very strong properties are like relatively more valuable, simply because like, yeah, we like need something. Like again, there's like, there are problems we see. We now have this like digital ecosystem that we're all kind of embedded in, and the question becomes like, how do we make sense of that? So yeah, it seems like Ethereum could become one of these institutions. So far I've tried to paint the picture that it's like heading in that direction, certainly, and that's really cool. But then there's a question, because of the nature of these like new like inputs and forces upon us, again, sort of just like the internet being like a blender for everyone's cognition, you would have to wonder like how can we stay aligned, which is everyone's fun hot word. And my answer to that is that we should focus on values. So this is something I think about quite a bit, like what are Ethereum's values? Like if there's one takeaway from this talk you should have, is that like basically
to the extent that we have challenges as we grow as a community, we should like lean to our values and use that to like help us make choices. So it's really important, like you should probably spend like most of your time thinking about what the values are, and then the other, you know, minority of your time thinking about how to like execute upon them. I've kind of come to like these three that I like. We'll walk through them. A big one is credible neutrality, which you probably hear all the time. Another one we'll call permissionless innovation. I'll explain that in a little bit. And this one I kind of made up, concrete optimism. Yeah. So credible neutrality. Vitalik has an article on this. That's probably like the sort of canonical text if you want to read that. But what do we mean, right? So neutrality is this idea that no one who's, like if you think of Ethereum as this like game and say a game theory sense, no one playing the game has any special advantage over like any other player. That's kind of the core idea. And it's not enough that you just have neutrality, because for other people to like really feel safe, let's say, playing the game, they also need to know that it is neutral and that everyone else also knows that, right? Like you get this like huge reduction in like this sort of strategy space of the game if everyone knows that like everyone's expected to play in a certain way. So this is what I mean with the credibility bit, that there's almost this like common knowledge layer. I'll draw an analogy here. There's this whole field of like development economics, which is basically saying, well, I would say like, and sort of insight from that field is that basically one way we can say that things develop in this like capitalism GDP sense is that the more that a nation state has these like strong property rights, the more basically everyone is better off over time. Simply because it like gives you some properties around, you know, I can own this thing and that I can also own in the future. No one will arbitrarily change the rules on me around like ownership of this capital. And yeah, there might be better systems, but this one seems to work at scale most of the time. And yeah, this last bit here, I was just trying to point out that we talk about these other things around like censorship resistance, immutability of the chain, you know, like code is law. I'll kind of claim these are like all consequences of credible neutrality, and ultimately we want to just have this notion that like there's some sense of like property rights in the legal sense, but in this like digital space. Permissionless innovation, I think this one's like a lot more clear. Basically, you can do whatever you want. Sometimes it's actually not what you want as a protocol designer, but it's here. This is good in terms of like state building, because it means that there's like possibly boundless opportunity for anyone to like join and play. And taken together with credible neutrality, okay, I have 5 minutes. I'll speed up. Credible neutrality and permissionless innovation, yeah, everyone's incentivized to join and play this game. Concrete optimism, I'm gonna gloss over this. Basically, I wanted to call out that like I think as a community, Ethereum's like very optimistic. We're like very hopeful, and like we're willing to try new crazy experiments, and generally think that we'll all be better off by doing so. So great, I've tried to paint like a nice picture for you. Does that mean it's it? Like we're all good? And basically no. The point here is that like the protocol isn't perfect. There's like rules we have, but they're leaky. We have these like leaky abstractions. A direct example here is like MEV, which that stuff has been said today, so I'll just assume you know what it means. And yeah, I mean, again, a like very sort of hot button, easily displayed example of this is OFAC censorship with all of our MEV infrastructure. This is a chart of validators, relays, and builders, and you can see there's quite a bit with these like red bars going on. This is from censorship.pix from Tony, you heard on the panel a minute ago. And yeah, so like the point here is just that there are all these unintended consequences. Like we can try to like make this nice set of rules, but like when they are put in the real world, it turns out that yeah, there's all these things we don't see that lead to issues. A big one is staking dominance, which I was going to drill into a little bit more. Restaking's here as kind of an example of like, you know, no one was talking about this even say a year ago, but now it's like this huge thing. MEV was a very similar thing a few years ago, and now the question is like, who knows what else will happen in the future, where suddenly it's like, oh, there was something we didn't think about with the way you could use Ethereum, and suddenly it could lead to like quite a problem. Right, so I was going to drill in here and speak to like staking. Again, a big issue most of you are probably familiar with is Lido dominance. So if we have, say, almost 900,000 validators, 31% of them are staked through Lido. That's not great. It should be obvious it's like a direct centralization vector. And I think ultimately, like a lot of the big issues are around soft power, just because it's like in the limits. Like imagine all the ETH is staked through Lido. Now basically their governance token is essentially the Ethereum governance token, but the Ethereum or the DAO governance token is not necessarily distributed in a way that aligns with like Ethereum community. So that's not great. Yeah, and to the extent that this happens, it like really starts to erode all these values I was just talking about. So that's not good. What can we do? So this is the thing Justin was talking about in the last talk around stake capping. You could imagine if we say, okay, it would be bad to, for example, have all the ETH staked in Lido. We could just say within the protocol we want to target a fixed amount. And we could just pick a number, say there's like 20% stake today. We say we want that. How do we get there? Well, we actually adjust the rewards curve in the protocol such that it becomes irrational to stake if there's more than 20% ETH in the protocol. And that's what this graph here is showing. That say, you know, at like 5% ETH staked, you get 5% APR, for example, and then it decreases down out to say like 20. That'd be cool. If we do so, then say there's like 20% stakes securing the protocol, 80% doing whatever else, all this like crazy application nonsense I was calling out. The issue with this is that MEV still exists. You know, take this as a shorthand for like all execution layer rewards. To the extent that this happens, you end up in a place where it adjusts the rewards curve down even more. And this becomes an issue because if we take the rewards curve that I had and just shift it down a bit, you get to this regime that I called on red of negative rewards. What this means in practice is that, for example, the individual solo staker, they're basically paying, say, one ETH a year to basically buy a lottery ticket to maybe get 10 from like some MEV block that they propose. This isn't great because bigger players are more well capitalized and able to like buffer these types of sort of payments because, yeah, they just have more capital to play this game. It's sort of law of large numbers. You end up in a place where they can play these games for longer than, say, the smaller players. That's not great. So is there a fix to this fix of stake capping, participation targeting? MEV burn has been floated. There's some ideas around how you'd actually try to capture the MEV in the protocol itself and either burn it, smooth it, do something with it. The issue here was this volatility in the rewards itself. Without this, basically you can't have this lowering of the curve and you end up in a spot where it's more like this. Some other ideas floating around, you can imagine every validator is like their own staking pool. I'll call it work here by like Dencun and Magnoiter at the EF. Rather than have like Lido or Rocket Pool, you could imagine a construction where like every validator has their own staking pool, their own LST. And that could be cool, but then you kind of have this issue where like the reason you have these staking pools in the first place is to like have fungibility around like the LST. And if like everyone has their own, then they're not immediately fungible and it's not clear how to do that. We could just give up and say, stat this money, call it a day. That's possibly not a good answer either. So yeah, I mean, what can we do? Basically keep doing what you're doing, like unironically, just like be aligned, and that's not just posturing, but what I mean by that is that we should live out the values that I called out earlier. When people disagree with you, try to incorporate their opinions, but ultimately have some principles used that you think are going to lead to a better future and act in accordance with those. That's it.
Perfect. We do have time for about maybe 1 or 2 questions if anyone in the audience has any. All right, not seeing any. Thank you very much, Alex, for an excellent, oh wait, there is one. Thank you very much. I missed it. Oh my gosh.
So given the set of values you mentioned and using them as a guiding principle, how do you feel about enshrining PBS?
Okay, this is a great exercise. So yeah, if we were to enshrine, you'd probably end up in a regime where you wouldn't have as much trust, say, in the relay. There's probably a lot more you could do around capturing MEV. That would all be good. And yeah, you would get to a place where, yeah, probably in the credible neutrality bucket, just saying that like there is this MEV sort of like metagame that's happening, but we can, by enshrining PBS in the protocol, you like bring that back into the protocol such that now it can be dealt with in a nice way. And suddenly the game we're all playing is like more level.
All right. once again, Alex, thank you very much for a very thoughtful presentation.
Thank you. Thank you, everyone.
It's kind of tough to be here after Alex. And
Excellent. I'm Ken. Very nice to meet you.
Nice to meet you.
How would you like to present?
I can just plug in HDMI, USB-C, yeah.
Would you like a hand mic or the podium mic?
I guess hand is good, yeah.
Okay, you ready to go?
If we are on time, I guess.
We're right up. All right, excellent. We'll go ahead and continue on. Our next speaker here is Mario. Mario, the Ethereum Foundation and Protocol Support. Welcome.
Thanks a lot. Oh, wow. I appreciate that, especially, I mean, it feels a bit weird standing here after Danny and Justin and Alex having, like, well, pretty serious talks and on very important topics. And, well, I also bring, important topic, but especially to stakers. And, I'm Mario from Protocol Support. And today I would like to tell you about ephemeral testnet, or actually more also in general specification of a new kind of testnet. Before we get into the testnet itself, maybe we should like give a overview of what testnets are even. But I guess I did hear you guys being stakers. I guess you experienced what testnet is or might be, and just in general, Ethereum is a network, so if we want to test things, we need to spin up a separate network where we don't handle real money, where we can just, play around with various kinds of stuff, and that can be in Ethereum the changes to clients themselves, changes to protocol, so testnets for protocol changing, or for protocol upgrades, or for users, and those can be, well, the developers creating contracts and all the applications on Ethereum, and you folks, stakers, who want to test your staking setups on testnet. So what is the current state of the Ethereum testnets when you want to do either of these? So after the merge, we killed some of the old testnets. The Robston is, as we call it, Ripston now. It's a terrible joke. But yeah, so what survived was Gurley and Sepolia. with them being dedicated to different use cases. Apolia mostly for users, for dev developers, and Gerli especially for stakers because it had the open validator set. I'm saying had because it's kind of history now. Gerli got deprecated in favor of new testnet, Holešovice, Holešky, named after Prague 7, which has also opened a validator set, and to be fair, pretty large validator set. It's 1.5 million validators, 3 times size of mainnet. So if you want to test your validator setup, Holešky right now would be the place to go, and it's still kind of fresh because it's just 2 months old now after a second successful launch attempt. However, these testnets are meant to run for many years to come. And as Gerli got deprecated for some obvious reasons, if you've been familiar with most of the supply issues with Gerli. So after the years of people, using it, testing it, draining the faucets, there is not enough testnet ETH in the faucets because there was only so much created in the Genesis. So one of the main problems that the testnets which are running for years encounter is that they just don't have enough ETH to just give out for free with like little proof of work from the users. So it can get expensive or hard to acquire some tokens for your testing. And what we saw with Gerli, especially with being it used for Praetor for many years, it not just wasted the funds, but also created many validators which just appeared for once. People just come and try their validator, and then turn off the machine. They switch to mainnet, and they're gone forever. So what we have is a bunch of inactive zombie validators, which cause missed blocks, or maybe, in worst case, even not able to. The network might not be able to reach the finality. And of course, as the network is growing, it gets older. It's growing. The state gets quite big, so you can have like hundreds of gigabytes of just testnet data if you want to run the node or try a validator. And and all of these will end dying anyway. So they are actually all ephemeral in a certain sense. So why don't we solve it in with more planned ephemerality? So we go back to Genesis. Ephemery, or this approach for testnet, which automatically goes back to Genesis, rolls everything back to Genesis. Right now it's every week, but it can be any given period. So ephemery itself is a name of a testnet which is running for, well, a year, almost a year now. It will be December, it was in December last year. We started the first iteration. And so, yeah, the testnet resets back to Genesis, which means all of the faucets are full again, all of the validators are clean and stable again, all of the state is gone. So I mean, it's just few gigabytes for the whole testnet again, while maintaining the same single infrastructure. Because if we have like Holešky, Gerli spinning up the new testnet, there needs to be, I don't know, Infura and all of these big providers need to switch spin up new nodes and start a new infrastructure. And Ephemery is achieving this with the same infrastructure, the same block explorers, the same nodes, just resetting the network. And that means that the faucets can be very generous. You can just waste it because they will get it back in a few days. And we can ensure that there will be always finality, because in the period when the testnet is running with the enough validators in the Genesis, there is not enough time for somebody to use all this free ETH to overtake the secure majority. So yeah, that's how it looks today. We have the iteration 101 already. Before it was the iterations were like 1 and 2 days, so that's why there is more than 50 of them, but it's been almost a year. And there are some resources, but I will show the link soon. So right now we have the weekly reset, and currently the testnet works in a way that it's mostly handled by scripts. It's a bash script, which is a reference implementation of the way how the Genesis is generated and the network resetted. Every week after the reset, it also deploys contracts, which are some basic primitives that you need on the network, so like the safe, etc. And all of this is specified as some general technology in its EIP, which is currently in review. Around the general roadmap, we've done such a path since the beginning, since the initial proposal. We are right now in the phase of client implementation and wider discussion with client teams. And yeah, so it's in the EIP-6110. That's a specification of, well, not just ephemery, but generally technology, a kind of testnet which allows this kind of reset. So the EIP specifies two functions. One is genesis function, which is deterministic degeneration of the genesis, because with each reset, the network actually needs to create a new genesis. It's not resting back to the same one, but to an iteration, to a new incremented values in a new genesis. This is necessary to well, keep track of the historical networks, to be able to protect from replay attacks, which would be otherwise possible. So basically the main part of the network is to be able to predict what will be the next iteration, the next generation, and it's actually pretty straightforward. The main thing is the timestamp of the genesis and the chain ID. So if you know the period, right now it's 1 week, and you know the previous timestamp, you are able to calculate when the other genesis after each week is supposed to happen, and each of it is iterated, the chain ID is iterated just by one. So yeah, the number of chain ID grows, and the genesis always, the timestamp, the time when the genesis occurs, when the network starts, is of course like just adding the period. And yeah, and one important point here is that, so this approach that we describe in the EIP is something which can be implemented in clients, which can be done in, you know, the Go Ethereum, Aragon, in Lighthouse, in Nimbus, and each of the clients themselves. However, it's fully backwards compatible, or it's compatible with the same implementation in the scripts. So right now the network is mostly running just on bash scripts, but the client which implements the same behavior as the script can just, you know, run in the same network and continue following the same ephemeral network. So yeah, here you can read all the details in the EIP. When you look into the authors, I just want to give shout out to Remy Piquet here, the co-authors of the EIP, because actually, so when the project started, when the initial ideas were gathered like a year ago at a Devcon in Bogota, the idea was to actually dedicate to stakers. We call it Stakers Testnet, because that was the main problem at the time, with Gerli not being able to provide ETH for stakers, and also make it very easy to just spin a node and then change it to mainnet. So folks from ETHStaker were very helpful in the initial phase of the testnet. And well, a year later, today, we have implementations and clients happening. So so far, Lodestar has implementation which is almost done. It has the main PR merged, and it's basically ready, and you can run it together with the other clients which are just using the scripts. With Get, Red, and Lighthouse clients, there's also implementation happening. It's in progress. There are also like prototypes which are not merged in clients, maybe don't have PRs, but they are. You can run the fork or contribute to these, and also dep node. So like the thing is that, again, this can be either client or some external dev tooling, some DevOps tooling handling how the node behaves. So it can be dep node or some other manager which is able to handle your system to restart the node when it's supposed to. So it's also being implemented in dep node as a separate package for ephemeral testnets. And so yeah, right now, based on the feedback from client implementers, from people working on the actual client code, we are just figuring some details which need to be smoothed out in the EIP specs. But that's mostly done. But we still need more tooling support, like, well, the dep node and other tools which are normally not counting on like changing every iteration, and need also either external script or implementation in themselves. And yeah, and the next step would be to push this to all core devs and have a wider discussion across client teams, because some are aware, but it wasn't brought up directly on ACD yet. And you can use it today. So yeah, as I showed before, I mean, it's there, it's running. So even if you don't run like the modified version of the client, you can use it, because you can just add it to your wallet. You can just connect to the RPC. There are multiple public RPC providers, and by using it, whether as a dev developer or a staker or running a node, you can find issues, provide feedback. That's something very, very helpful. If you find any missing infrastructure that you would request or provide or help with all of this tooling, we will be very much happy. So it's especially useful if you want to do any form of short-term tests. So like if you are a developer learning Solidity and you're going to do Hello World, and then you're going to do like basic calculator, or like the basic sort of contracts that you deploy to, instead of to Garly or Holeshki, instead of like bloating their state, you can just put it on ephemery. It's going to be done in a week, but your Hello World contract doesn't have to be there forever. So just use it for infrastructure that you don't need next week, and also for a validator. If you just want to try how the validator setup looks like, and what you need to do, how to generate the keys and connect it to the network, you can use ephemery. You can run the validator for a few days, then it resets and you need to do the deposit again. You will also get reimbursed at the end of the period. You in the next period you get your test Ether back actually, but validators currently need to be run only for a few days, but it should be enough if you just want to do some simple tests. And yeah, it will be very fast. It will be very easy, because well, the week-old network has really like few megabytes, few gigabytes. It's going to sync like this. So yeah, you can run it on a small machine. You can easily test it out. Maybe even if you don't have a big proper machine for a mainnet heavy full node, you can just play with this, and it will be much lighter than Sepolia, which is running for 1.5 years, or Holeshki, which has shit ton of validators. Yeah, you can break anything. Yeah, if you manage to break something, we'll be very happy. So please join our Matrix channel and let us know about what you managed to break, what you are missing, what issues did you find. You can find all of these resources in ephemery.dev, which is the landing page where you can add it to your MetaMask and find all the details. And it is the Matrix group. You can join us at this QR code if you're interested in joining the community and chatting with contributors about ephemery. And we have meetup on Thursday. If you would like to meet us, people working on ephemery, the ephemery community contributors, join us on Thursday at 5 in a restaurant which is nearby here. You can find it on the Twitter or in the Matrix channel. It's pinged there. So yeah, I'm not sure if I have extra time to take some questions, but I guess that's it. Yeah, thank you so much. Yeah, thanks everyone. Oh, I get some stickers. If you stop by, I will have some ephemery stickers for you.
Any questions from the audience here?
That was quick. Yeah, thank you so much.
All right, thank you, Mario.
Yeah, thanks a lot. Good.
Will be at 4:35. All right, welcome back, everybody. We're down to our final sets of talks here. Pleased to introduce the next speaker. It's Darren Langley, who is the General Manager for Rocket Pool.
Thanks. All right. Hey everybody. I'm Darren Langley. I'm from Rocket Pool. So Rocket Pool is the second largest liquid staking provider. We're a liquid staking provider. So we have over 3,000 independent node operators in about 100 different geographic locations. We account for about 3.5% of all of the ETH that's being staked today. So today I'm going to be 8. It's kind of like an obscure and small EIP, but it has a major impact on the staking space. And in fact, as a staker, you should be very excited that this EIP is going to be coming next year. So I should have jazzed up the title a little bit. This is a better title. The name of the EIP is a bit generic, but this goes to show that it is actually a big deal. Okay, so what does EIP-4788 solve? Okay, so currently there are still really, from a smart contract perspective, there are still really 2 chains. We've had the merge, and that's fantastic. But from a smart contract perspective, the smart contracts don't know about anything that happens on the consensus chain. Right? The smart contracts live on the execution chain, but they have no visibility of what goes on the consensus chain. Now, in most cases, this separation is actually a good thing, right? But for staking applications and staking protocols, this is it poses a bit of a challenge, okay? So imagine a staking protocol, and there's a staking protocol here in orange. You'll notice that. So this staking protocol is a bunch of smart contracts sitting on the execution chain, okay? And the issue is that it needs to get information from the consensus chain, but it can't. So staking providers or staking protocols, what they do is they implement an oracle, all right? Now the oracle transfers information from the consensus chain to the execution chain, inputs into the smart contracts, so the smart contracts have that information. The issue is that the smart contracts have no idea whether what the oracle has given them is actually the right thing, okay? They have no way of verifying that they've done that. So in a staking protocol situation, the oracles have to kind of like we have to rely on like an honest majority or like reputation or some sort of social leverage to make sure that the oracle is doing the right thing. Now, that sort of oracle system works well enough, but it's not ideal because we've introduced some sort of level of trust in the system, and which we don't want to have. The other big problem with having these oracles is that they can become gatekeepers. So they're needed. Let's say, for example, that you need a participant that submits some data, and you need an oracle to then check that data to make sure it's correct from the consensus chain point of view. Then they become gatekeepers, and you don't want that either. Okay, so what is EIP-4788? So what it does is it provides trust-minimized access to consensus information. So it helps staking protocols, restaking infrastructure, some MEV applications, and to be much more efficient. It also promotes a lot of innovation within the staking space. The amazing thing about this is that it is coming next year. So Dencun is kind of in testing at the moment. They're going through the hard forks on the testnets, and so that will be available next year. as somebody who kind of builds or helps to build a decentralized staking protocol, I cannot wait for this to be in Ethereum. It opens up so many opportunities, and as a staker, you should be pretty excited about the future. And we'll get into that in a minute. So, how does it work? So, the consensus block has some really interesting information in it, okay? It has validator statuses, or well, sorry, the state root has lots of information in it. So it has the validator status, has the validator balances, whether validators have been slashed. It has exits in there. It also has a lot of performance information as well. Now, what they do is there's a Merkle tree that contains all this information, and that's all bundled up into this hash tree root, which is at the top. So this kind of like string is the root that you can then use to verify any piece of information within that block. So in other words, you can verify from that hash tree root, you can write a proof that verifies any piece of information within that within the consensus kind of block and block state. So EIP-4788, what it does is it puts the consensus block root in the execution block. Technically, it's the parent of the consensus block, but I'll skip that because it's complicated. So that's now available within the block. This isn't that helpful, particularly for smart contracts, because ideally, from a smart contract perspective, you want to be able to get a block root for a particular time period or at some point in the past. And so that's not necessarily as useful, but it becomes a bit clearer in a minute. Okay, so along with that kind of like beacon state root in the execution block, you've also got a new smart contract that's going to be deployed called, it's actually called the beacon root contract, but for consistency I've called it the consensus root contract. The idea behind this smart contract is it enables any smart contract to be able to query for an individual block root. And so you can essentially give it a time, and it will give you back what that block root was at that slot. One of the things about this contract is it uses this thing called a ring buffer, so that the state doesn't keep growing and growing and growing. That ring buffer lasts for a day. So essentially what that means is that you can query block roots for within like 24 hours or a day, okay? How the block roots actually get in there is, so now I've got to remember, there's the consensus clients, or execution clients, sorry. The execution clients submit the block root each time it executes a block. And so they actually put that in there so it's available for querying. All right, let's give you an example so that you can kind of like see how all these pieces work, right? So let's say, for example, we want to give a NFT to anyone who's been on validating on the beacon chain for over a year, all right? So the idea here is that some validator would call this mint function on the NFT. They would provide a proof to and the values for a certain information, right? So they would provide the withdrawal address for the validator, the activation epoch, and the exit epoch, and they would call this function from the withdrawal address, okay? So that you can kind of link that it belongs to that validator. What the mint function will do is it will go to the consensus root contract. It will get the consensus root for that particular slot. It will then use that and this proof, or actually verify this proof against that root to make sure that those values are as expected. What it'll also do is it'll check the signature to make sure that it's from the withdrawal address, and then you can prove that the person who's submitting this is actually the owner of the validator and that they have been validating for more than a year. And at that point, you can then issue them with an NFT and everything's great. So this is a bit of a trivial example, but you can actually take the basic concepts of this, translate it into staking protocols, and you get massive impacts for the state of staking today. So, what are those impacts? So, what the future looks like is you start to become a lot less. There's a lot less trust. So, at the moment, these staking protocols need these oracles, but with this beacon state root, we can essentially get rid of those oracles and replace them with trustless processes instead of like processes that use trust. So what that means is you can actually move it from these kind of like trusted actors to participants of the network. So in our case, for example, moving it from oracles to our node operators. Because it's trustless, you know, and a staking protocol shouldn't really trust the node operators, or at least a decentralized staking protocol doesn't trust their node operators, and so we have to have these trustless processes for it to work. So what this does is it introduces that, so it means that there's no need for these trusted kind of oracles anymore. The other thing is efficiency, and this is probably where, you know, from a staker it becomes a little bit more interesting. It becomes a lot more efficient and a lot lower costs, because the information is we can verify the information a lot quicker. We don't need these oracles to send over the information. It can all be done in a kind of a trustless way by somebody submitting the information themselves with a proof, and then we can verify that that is absolutely correct. It also there's a lot of efficiency improvements within that. So, you know, from if you're a liquid staking token holder, or if you're a node operator within these staking protocols, this is going to make a big deal to you. The other thing is around innovation. So, you know, there's a great opportunity to improve the current staking protocols, you know, that exist today, but also whole new types of staking protocol, or different ways of kind of doing this similar thing, but in a much more efficient way. Okay, cool. So what are the resources? So the EIP itself is actually quite approachable. I'd kind of recommend having a read. There's actually a brilliant series called Peep and Eep from the Ethereum cat herders. This one in particular has Alex Stokes going through the design decisions around EIP-4788, and actually a big shout out to Alex, because he's kind of pushed this EIP very, very well. Yes, thank you very much. Long story short, EIP-4788 is going to change the staking landscape. It's a very important EIP, even though it's a very small one, but yeah, be excited for the future. That's me. Thank you.
We certainly have times for any questions here. I see some.
Hey, thanks, Darren. Can you just explain again the purpose of the ring buffer in the contract?
Yeah. So so basically, we don't want the state to kind of like grow and grow and grow, because it means that that's going to cause a lot of chain bloat. So the idea behind this is to have a ring buffer that keeps it to just a day's worth of block roots. In general, a day is perfectly fine. You only really need it for a few. You need enough time for like a few blocks maybe to make sure that transactions can get processed. But in general, you know, a day is ample for this sort of application.
Any other questions? All right. Well, once again, Darren, thank you very much for an excellent presentation.
Thank you.
I don't think we have our next speaker, Mike, here yet. We are running a little ahead of schedule, so Mike is scheduled to talk at 5:10 p.m., so we'll resume at 5:10.
sorry, sir.
Yeah, 30 seconds. Yeah, no worries, no worries.
But people should be coming, yeah?
This might be about it. End of the day. Yeah.
I mean, if there is a snacks out there, maybe they are eating snacks and forget to already register. Coffee break, etc.
Yeah, could have been. But there's people watching online, I think, so they were gonna do it at 5:10.
By the way, how are online watching counts? How many people are watching?
Yeah.
Online. Is it to your liking?
Yeah, but
it's expected, right?
we know that people will watch on demand. Like you will not watch live.
Yeah.
Right, I understand.
Okay. All right. Well, thank you all for staying with us this late into the agenda. This will be our last talk here. And I'm very pleased to introduce onto the stage Mike Silagaze, who is the CEO of Ether.fi. Mike.
Hi, everyone. I've got a chest thing going on, so if I cough up a lung periodically, don't mind me. Okay, so thanks for those of you that are here for coming to the talk. I'll try to keep it brief and kind of conversational. If you have any questions or whatever, just shout it out. Just to make it more interactive. So I'm the founder and CEO of Ether.fi. Ether.fi is the newest liquid staking protocol. There's two things that make Ether.fi interesting. The first is it's the only protocol where the stakers get to control their keys, specifically both the validator key and the withdrawal credentials. That's really, we believe that that's essential for making the protocol truly non-custodial. The second thing that's particularly interesting in the current kind of excitement around restaking is that Ether.fi is the first liquid restaking token. So it's natively restaked on EigenLayer and with plans to integrate other restaking protocols. So we're pretty excited about that. We just raised our seed round of financing, a $5 million round with some great investors. That was about 6 months ago. And then we actually just went to mainnet on Friday. So that's very exciting. Currently it's whitelist only, but actually everybody who's on the whitelist is going to be off the whitelist and able to stake tomorrow. So very, very exciting times. Okay, so I'm going to talk a little bit about the mechanics of restaking and why native restaking is particularly interesting. I assume, just given the audience and where we are, that you guys know about staking, but I'll give a quick blurb about what restaking is and why native restaking is particularly interesting versus, let's say, non-native restaking. Okay, so restaking, again, I imagine most people here have heard about it. But the basic idea of it is, you stake your ETH, and that gives you the right to run a validator on Ethereum and get a share of the, the revenue that Ethereum produces, various sort of slices of revenue. The idea is, 32 ETH is a lot of ETH. What if you could reuse that same staked ETH as effectively collateral to run validators for other services? So other services might include other blockchains, might include data availability layers, Oracle networks, or a variety of other services. What you're really doing with restaking is you're kind of expanding the Ethereum trust layer to encompass other stuff outside Ethereum. Lots of risks associated with this have been discussed, and they're totally valid. But the upside is pretty significant. If you can imagine a lot of other stuff kind of getting plugged into and utilizing the Ethereum security layer, a lot of value then starts occurring to ETH. It's hard to place a number on that value, but it's not hard to imagine that actually ending up being pretty large. And as far as, let's say, a node operator or a staker, it's not hard to imagine that eclipsing, in fact, the value of sort of basic staking. If only because, it obviously will lead to more ETH being staked, and therefore, lower staking rewards, native, basic staking rewards for everybody, but lots and lots of, hopefully, restaking rewards. So it's a very exciting, fraught with risk, but very exciting opportunity. There's one major player in the restaking world, and that's EigenLayer. Again, I imagine most of you guys have heard of them. But there's others that are starting. So there's Restaking Cloud from BlockSwap, which is really interesting and takes a different approach. And there's lots of other teams that are working on different aspects of this. With Ether.fi, our hope is to become kind of like the restaking router that's like your one-stop shop for staking that's natively integrated into restaking. That's what we're trying to do. Okay, so let's talk about very basic, normal, organic, fresh, locally farmed staking. The way you stake is you've got your keys, so you got your validator key, you've got whatever you're using as your withdrawal credentials. You call a function on the Beacon Chain deposit contract, send it 32 ETH, and then when you want to unstake, you do a voluntary exit on your validator, and then the ETH magically shows up back to wherever you want it to be withdrawn. Very simple, kind of this closed loop process. With native restaking, so let's say you want to inject EigenLayer or some other restaking solution into this, you do the same thing. You deposit your 32 ETH into the Beacon Chain deposit contract, but you point your withdrawal credentials to an EigenPod smart contract. So instead of pointing it to your own wallet or some other, Gnosis safe or some other smart contract, you point it to an EigenPod withdrawal contract. EigenPod is, has all kinds of EigenLayer magic associated with it. That is basically providing the capacity for programmable slashing. So if you're running a validator, then that validator is also running other restaking services. Like let's say it's running an Oracle, it's running a data availability thing. Then if that validator misbehaves, the EigenLayer contracts will slash your ETH. So when you go to unstake it, you instead of getting your 32 ETH back, you're going to get some fraction of that back. And you can stack as many services, in theory, as many services you want. On top of that, obviously, again, lots of risks, et cetera, but also you can also increase your staking revenues that way. That's the basic idea. The key thing is your withdrawal credentials are now pointing to an EigenPod that has programmable slashing baked into it. So this is native restaking. Non-native restaking is kind of a weird, kind of interesting thing. And I'm talking specifically about EigenLayer because they're doing it, where you take a liquid staking token, like let's say STETH, but really it could be any token. It could be Maker, it could be wrap Bitcoin, it could be whatever. It could be SHIB, Pepe, whatever coin you want. You put it into an EigenLayer contract, kind of sits there, and then the EigenPods are able to programmably slash some other validator that has nothing to do with the tokens that you just deposited. So really, non-native restaking is, it's not staking, it's also not restaking. It actually has nothing to do with either. Really what it is, it's a way to build TVL, which is a totally good, solid strategy on the part of EigenLayer, makes a lot of sense. If you wanted to actually build a staking, like AVS's services on top of this, you need to have the validators then put up a separate bond. Otherwise, they have no economic incentive to not misbehave, right? You need to either have them put up a separate bond, or you only work with trusted node operators who have a reputational risk associated with it. But again, it's like, well, then what does this have to do with restaking? It's not, So my position is the only kind of restaking that actually makes sense is native restaking. For that reason, that's why with Ether.fi, the way our protocol is designed is when ETH goes into our protocol, we do this. In other words, we actually spin up validators that are natively restaked that point to EigenPods, and then when you go to redeem your ETH, we have a mechanism. I briefly mentioned that stakers hold their keys. We have an economic mechanism that incentivizes bondholders to exit the validator, and then the ETH comes back, whether it's slashed or not. But then you can actually sort of address directly a particular validator that may or may not be misbehaving that's actually running the additional service, as they say, Oracle Network or whatever it happens to be. So we think that makes sense, and we have the luxury, being sort of late in the staking game, to have built our protocol this way. Obviously like Lido and Rocket Pool, which are great protocols. Restaking wasn't a thing back then, so the protocols are designed in such a way that they would need to be substantially redesigned to support this kind of thing. So that's pretty exciting. Where are we at now? I think I mentioned we raised a round of financing. October 11th, we did our testnet launch. Went well. We finished our audits a few weeks back. We're also, I think, still running an audit contest with HATS Finance. So if you want to win some money, come and submit some bugs. And then we launched on mainnet, and then this tomorrow we're actually turning off the whitelist and allowing anybody to stake. So come check it out. Give us some feedback. Join our Discord. All that good stuff. And thanks for listening.
Are there any questions from the audience?
So if I would like to participate as a staker in your protocol, then which AVSs I could choose to put my staked ETH on?
Yeah, so there's multiple ways to participate in Ether.fi. If all you want to do is stake ETH, then you would just mint ETH, our liquid staking token. And then all the work is sort of handled by the protocol. We currently don't have a governance DAO. We probably will have one in the future, and that's how the AVSs that we support will be determined, and the particular allocation to those.
But then you use...
So the easy button is the just stake ETH, and that's it.
But then you also use a liquid staking token, so you don't use the native restaking approach.
The liquid staking token is backed by natively restaked ETH. So it goes into a pool, that ETH in the pool gets natively restaked, and the liquid staking token can then be redeemed by, let's say, exiting validators or using the buffer in the pool. However, if you want to run a validator for us, you can do that one of two ways. You can either bond 2 ETH, so it's a 2 ETH bond requirement, and then run a validator, and then you can decide, do you want to restake, do you not want to restake, which AVSs you want to run. You basically do whatever you want because you're running the validator. Or we actually have a program we've been running called Operation Solo Staker, and that actually allows people to run a validator without providing a bond, but it's a permission thing. So we vet everybody that does that, and we use DVT to distributed validator technology to kind of make it lower risk for the protocol to stake with those validators. So if you go to Ether.fi, you can apply to be a solo staker on Ether.fi.
Excellent. Any other questions for Mike? All right. Well, thank you very much for an excellent presentation.
Thanks, everyone.
That concludes our programming for this conference. I wish you all safe travels and the rest of a great Dev Week.